सूर्य वाला भेज दिया।
इस तरह L1 पलटे गए।
चला ना लाइव करो चलता नहीं।
बिना किसी
ये तो अभी बैग चल रहा है, मेरे चैनल पे नहीं हो रहा है।
यह अंतरिक्षयान विद्युत चुंबकीय और कण चुंबकीय
इसको चलने वाला है।
पंपों का उपयोग करके
स्टार्ट हुआ
और सूर्य के सबसे बाहरी पर कोरोना के नाम से जानते हैं, इनका निरीक्षण करने के लिए इसमें 7 निदभार लगे हुए हैं। इनमें से 4 निदभार सीधे सूर्य की गतिकी का अध्ययन करेंगे तथा अन्य 3 निदभार L1 बिंदु पर कणों और क्षेत्रों का यथास्थिति अध्ययन करेंगे। इस तरह आदित्य L1 उपग्रह के निदभार कोरोनल तापन, कोरोनल मास इजेक्शन, प्री फ्लेयर और फ्लेयर गतिविधियों और उनकी विशेषताओं और अंतरिक्ष मौसम की गतिशीलता को समझने के लिए अत्यधिक महत्वपूर्ण जानकारी प्रदान करेंगे। अब आपके सामने प्रस्तुत है आदित्य L1 कर्टेन रेजर।
reaching extremely high values of 1 to 3 million Kelvin. The Aditya L1 mission has 7 scientific payloads to conduct a comprehensive study of the Sun. The Visible Emission Line Coronagraph, VELC, investigates the solar corona and the dynamics of coronal mass ejections. The Solar Ultraviolet Imaging Telescope, SOOT payload, scans the solar disk in near ultraviolet light and detects fluctuations in solar irradiance. The Aditya Solar Wind Particle Experiment, ASPECS, and Plasma Analyzer Package for Aditya PAPA payloads investigate the solar wind and energetic ions, as well as their energy distributions. The Solar Low Energy
We are 17 minutes 23 seconds from the launch time. The countdown for PSLV C-57 Aditya L1 mission has been 24 hours long. It had started yesterday. During the countdown, critical activities have been carried out on the launch vehicle and the spacecraft. The propellant have been serviced into the launch vehicle stages. The bottles storing the gases for command and control operations have been charged to pre-launch pressure levels. The onboard batteries have been charged.
Confirmed external hold mode.
Now in a little while we'll go to the automatic launch sequence initiation, for which the preparations are underway in the launch and mission control centers.
ROD to Mission Director. Range is ready for PSLV C-57 Aditya L1 mission.
Mission Director Roger. TTC Director to Mission Director.
Confirmed external hold mode.
Confirms readiness of all extract stations and network for supporting
अभी आपने सुना
C-57 Aditya L1 mission. Mission Director Roger.
उपग्रह निदेशक,
TCTC,
रेंज निदेशक,
data lovers of
टेलीमेट्री
SHAR 1,
टेलीकमांड
SHAR 2
निदेशक
station.
तथा यान निदेशक
TCTC
ने
cockpit.
अपने तंत्रों की सूचना मिशन निदेशक को दे दी है। इसके पश्चात
T-16 minutes and
सभी
counting.
आंकड़े संतोषजनक होने पर
Mission Director, Mission Readiness Review and Launch Authorization Board have already given clearance for proceeding with the countdown and launch of PSLV C-57 Aditya L1 mission. All operations in the countdown sequence till automatic launch sequence have been completed satisfactorily. Based on the clearance obtained from launch vehicle, spacecraft, range and distract network stations and prevailing favorable weather conditions, Mission Director hereby authorizes to initiate launch operation sequence for the launch of PSLV C-57 Aditya L1 mission at 11:50 hours IST today, that is 2nd September 2023.
All stations to note, Mission Director has given authorization for the launch of PSLV C-57 Aditya L1 mission.
SDS servers activated. MC
अभी
confirms
आपने
data
देखा
from SHAR 1
इस
and
मिशन
SHAR 2.
के मिशन डायरेक्टर श्री
T-minus
SR
15
बीजू ने
minutes and counting.
इस मिशन का
Hereby authorizes to initiate automatic launch sequence for the launch of PSLV C-57 Aditya L1 mission.
Automatic launch sequence initiated for PSLV C-57 Aditya L1 mission.
The automatic launch sequence, the initiation has been announced, and hereafter a very critical capsule of performance validation for the launch vehicle systems will be carried out, and very close to the launch time, control will be passed on to the onboard computers.
जी हाँ, ऑटोमेटिक लॉन्च सीक्वेंस चालू हो चुका है। ALS शुरू होने के पश्चात रॉकेट स्वचालित होकर सर्वप्रथम T-0.3 सेकेंड्स पर RCT का प्रज्वलन शुरू करेगा और T0 पर कोर बूस्टर S139 का प्रज्वलन शुरू होगा। लेकिन इस दौरान वह स्वचालित तरीके से सभी जांच जारी रखे हुए है।
PS2 control system, redundant chain actuation in progress.
On your TV screens, Honorable Minister of State for Science and Technology and Prime Minister's Office, Dr. Jitendra Singh. This mission is the 91st launch mission of ISRO and 59th of Workhorse PSLV. As mentioned earlier, PSLV's XL version with 6 strap-on motors alongside the core S139 motor is being used for the present mission. This is the 25th time PSLV XL is getting ready for launch. So far in the year 2023, ISRO has launched SSLV's maiden successful mission, 2 commercial missions of PSLV, 1 mission of GSLV carrying the first among the second generation of navigation satellites, 1 commercial mission of LVM-3 and another mission of LVM-3 again carrying the prestigious Chandrayaan-3 spacecraft.
PS4 control system actuation in progress.
आदित्य L1 जो कि एक अंतरिक्षयान है इस मिशन का, इसको पृथ्वी से 235 बाई 19,500 किलोमीटर की निम्न भूकक्षा में 19.2 डिग्री के झुकाव के साथ अंतक्षेपित किया जाएगा। इस कक्षा में निर्धारित आर्ग्यूमेंट ऑफ पेरिजी 346.6 डिग्री को प्राप्त करने के लिए PSLV के चतुर्थ चरण को 2 बार प्रज्वलित कर इसे प्राप्त किया जाएगा। आर्ग्यूमेंट ऑफ पेरिजी असेंडिंग मोड और पेरिजी के बीच के कोण है जिसे कक्षीय तल के साथ मापा जाता है। आदित्य L1 के इस दीर्घाकार कक्षा में अंतक्षेपण के पश्चात उचित समय पर और उचित अभिवृत्ति में अंतरिक्ष यान में लगे लिक्विड एपोजी मोटर्स को फायर कर कक्षांतरण किया जाएगा और इस तरह 5वीं बार में LAM मोटर को फायर कर यान को पृथ्वी की प्रभावी क्षेत्र से बाहर निकलने में समुचित गति प्राप्त की जाएगी। फिर वह पृथ्वी की कक्षा से छोड़कर सूर्य की कक्षा में प्रवेश करेगा और ऐसा करते हुए यह करीब 125 दिनों का समय लगेगा। 125 दिनों बाद यह L1 पॉइंट के पास पहुंचकर और उसकी परिक्रमा करना शुरू कर देगा और यही वह L1 पॉइंट है जहां पर से यह अपने वैज्ञानिक उद्देश्यों का भी प्रतिपादन करेगा। अब हम उड़ान से 11 मिनट की दूरी पर
control system activation in progress.
Let me in the meantime tell the viewers about the flight events that the launch of PSLV C-57 Aditya L1 will take. This mission is among the longest flights of PSLV. It is going to last for 63 minutes and 19 seconds. The liftoff coincides with the ignition of core S-139 solid rocket motor and the ignition of the 4 ground-lit strap-ons. While the rocket is at 2.7 kilometers altitude, the 2 air-lit strap-ons also commence their operation. The action time of strap-on motors is 70 seconds and the ground-lit and air-lit strap-ons are separated from the ongoing launch vehicle at 70 and 92 seconds into the flight, respectively. The core S-139 motor continues to thrust till 110 seconds. Since the second stage of PSLV operates on pressure-fed liquid engine, the optimal performance of the engine is ensured if the effect thrust cutoff or separation of the lower stage is countered by additional means of thrust generation. Therefore, the alleged motors provided for this purpose ignite 3 seconds before the first stage separation and continue to thrust for 11 seconds. The second stage, PS2, commences its operation 200 milliseconds after the separation of first stage. By this time, the rocket would have attained 55 kilometers altitude. The closed-loop guidance is initiated, which compares the present state of rocket to the intended injection point to compute an optimal trajectory. This happens while the rocket is at 59.7 kilometers altitude. At 204 seconds into the flight, the payload fairing is separated as the launch vehicle attains 113 kilometers altitude and the dense atmosphere is no longer present around. These events are taking place in the operational regime of the second stage, which lasts for 153 seconds. PS2 was separated 262.4 seconds into the flight at an altitude of 130 kilometers, while the relative PS3 ignites about a second later and burns for 118 seconds, during which time it adds 12 kilometers to the altitude and enhances relative velocity tremendously from 4.9 kilometers per second to 7.3 kilometers per second. There is a coast phase of 200 seconds that follow PS3 burnout, during which there is no thrust being developed, but the rocket continues to be steered. At 581 seconds into the flight, the PS3 separates and the last in the fourth stage of the rocket, together with the Aditya L1 spacecraft, coasts for a long time thereafter. Till 1396 seconds into flight, the tracking stations at SHAR, Port Blair, Brunei and back will be acquiring the real-time performance data of the flight. But thereafter there is no visibility period of around 1600 seconds or 27 minutes. The fourth stage burns twice. First time for a duration of 30 seconds and second time for a duration of 472 seconds. The first burn takes place in no visibility zone, and the second burn is tracked by a shipborne terminal placed in Pacific Ocean. About 200 seconds after the completion of second burn of PS4, the injection conditions for the separation of Aditya L1 are expected to be achieved. An altitude of 648.7 kilometers and a relative velocity of 8.9 kilometers per second, which translates into an orbit of 235 by 19,500 kilometers. The injection event of Aditya L1 will be confirmed by tracking station at Koru. From the initial placement in ground orbit raising, and eventually it will exit Earth's sphere of influence to reach Lagrange's point L1 in a journey spanning over 4 months. There it will be placed in a halo orbit around L1. This is how India's first observatory class space-based solar mission will take shape.
Vehicle is in internal battery power.
अब हम उड़ान से 6 मिनट की दूरी पर हैं। ALS जारी है। सभी जांच सुचारू रूप से जारी हैं। इस दौरान यहाँ उपस्थित आप देखिए, यहाँ
External power supplies are withdrawn.
व्यूअर्स गैलरी पे, लॉन्च व्यू गैलरी पे उपस्थित जन आक्रोश, इनका रोमांच देखते ही बनता है। इतनी मौसम यहाँ लगभग 37 डिग्री का टेम्परेचर है, वायु गति 0.8 मीटर पर सेकेंड। इन सब के बावजूद यहाँ उपस्थित हुए हैं इस रोमांच को देखने के लिए। एयर ट्रैफिक कंट्रोलर और मौसम विभाग की अनुमति भी प्राप्त की जा चुकी है। विभिन्न ऊंचाई पर वायु गति माप ली गई है और इसे ऑनबोर्ड कंप्यूटर पर लोड कर दिया गया है।
The Satish Dhawan Space Center has its own meteorology department which keeps a very close watch on the weather at the launch base. Weather today is going to be dry and hot. The skies will remain clear. Ground winds will be benign and upper winds also are benign for the flight of PSLV C-57 Aditya L1 mission. We are 4 minutes, 23 seconds to the launch.
सभी वैज्ञानिक अपने कंसोल पर आंकड़े देखते हुए सभी तंत्र सामान्य निष्पादन कर रहे हैं। अब हम 4 मिनट की दूरी पर हैं उड़ान से।
T-4 minutes and counting.
सामान्यतः PSLV के मिशन लगभग 2000 सेकेंड में प्राप्त कर लिए जाते हैं, लेकिन यह मिशन कुछ अलग है। इस मिशन में PSLV के चतुर्थ चरण यानी PS4 को 2 बार में प्रज्वलित कर यह उद्दिष्ट कक्षा प्राप्त की जाएगी। इसका मतलब PS4 को प्रथम कोस्टिंग फेज के बाद प्रज्वलित किया जाएगा, फिर 30 सेकेंड प्रज्वलित रहकर यह बंद हो जाएगा, फिर करीब 1600 सेकेंड की कोस्टिंग फेज जारी रहेगी। तत्पश्चात फिर से PS4 को प्रज्वलित कर 472 सेकेंड तक प्रणोद उत्पन्न किया जाएगा और फिर शांत हो जाएगा। आदित्य L1 के कक्षा की स्थिति प्राप्त होते ही उसे निर्दिष्ट कक्षा में अंतक्षेपित किया जाएगा। इस तरह पूरे मिशन में लगभग 3800 सेकेंड का समय लगेगा।
T-3 minutes and counting.
यह PSLV C-57 का प्रमोशन यान ट्रैकिंग के संदर्भ में भी काफ़ी जटिल है। इसे ट्रैक करने के लिए शॉर, पोर्ट ब्लेयर, ब्रूने और बैग स्थित ग्राउंड स्टेशन हमें वास्तविक समय पे यान की जानकारी उपलब्ध कराते रहेंगे। लेकिन चतुर्थ चरण के प्रज्वलन के समय यान हमारे ग्राउंड स्टेशन की दृष्टि से दूर जा चुका होगा, इसलिए शिपबोर्न ट्रैकिंग या शिपबोर्न टर्मिनल को दक्षिणी पैसिफिक महासागर में स्थित किया गया है। वह हमें PS4 बर्न 1 और बर्न 2 की जानकारी उपलब्ध कराएगा। इसके बाद PS4 शट ऑफ और आदित्य L1 के अंतक्षेपण की पुष्टि कुरु फ्रेंच गयाना स्थित ग्राउंड स्टेशन से की जाएगी।
T-2 minutes and counting.
अब हम उड़ान से 1 मिनट 50 सेकेंड की दूरी पर। यह PSLV की 59वीं उड़ान होगी और इस PSLV एक्सेल संस्करण में यह 25वीं उड़ान है। इसरो के वर्क हॉर्स कहे जाने वाले इस रॉकेट कई ऐतिहासिक मिशन को सफलतापूर्वक संपन्न किया है, जिसमें चंद्रयान 1 और मार्स ऑर्बिटर मिशन उल्लेखनीय हैं। यह प्रमोशन वर्ष 2023 का 7वां मिशन होगा। इस साल की शुरुआत में SSLV के सफल प्रमोशन से शुरुआत कर LVM-3 के 2 प्रमोशन, GSLV Mark II का 1 और PSLV के 2 सफल प्रमोशन हो चुके हैं। यह PSLV का वर्तमान वर्ष में 3रा मिशन है।
All stations stand by for the time mark. T-1 minute and counting. -55 seconds.
All subs are armed.
-50 seconds.
All sequencers armed.
तो हमारे साथ बने रहिए। अब 40 सेकंड पर
-40 seconds.
प्रमोशन किया जाएगा।
VHPP open.
-35 seconds. -30 seconds.
Real-time programs activated.
-25 seconds.
PS2 VSPP open.
-20 seconds.
PS on ignition RMS arm.
-15 seconds. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. +5 seconds.
Lift off normal.
P1 tracking.
P3 tracking.
Magnificent lift-off of PSLV C-57 with Aditya L1 on board.
+15 seconds.
PSLV C-57 का सफल उत्थापन और इसके साथ
20 seconds.
प्रथम भारतीय सौर अंतरिक्ष यान निकल चुका है सूर्य के तेज से विज्ञान को प्रकाश करने।
Air lead strap on ignited.
इसके साथ ही एक और कदम है अंतर्ग्रहीय सफर में भारत की उपस्थिति सिद्ध करने का। आप देख रहे हैं PSLV C-57 प्रथम चरण पूरी तरह सामान्य।
The rocket flying forth, following nominal trajectory and developing nominal thrust. The bright fumes against a clear midday sky. A rocket launch is more than just a sight to behold. The roaring sound and the vibrations that we can feel here, adding to this, the thrill are just amazing. Ground lit and air lit strap-ons operating together with the first stage S-139.
Ground lead strap on separated.
जैसा कि निर्धारित है ग्राउंड लेड स्ट्रैप ऑन को सेपरेट कर दिया गया है और प्रथम चरण का निष्पादन सामान्य है। इस घटनाक्रम में अगला एयर लेड स्ट्रैप ऑन को यान से पृथक कर दिया जाएगा।
Air lead strap on separated.
जी हाँ, इसकी भी पुष्टि हो गई है। स्ट्रैप ऑन को सफलतापूर्वक पृथक कर दिया गया है।
We are 100 seconds past the launch time. The ground lit and air lit strap-ons have been separated. S-139 motor still thrusting.
S-139 110 सेकंड के प्रज्वलन काल के पश्चात उसे भी पृथक कर दिया गया है।
+2 minutes.
द्वितीय चरण जो कि तरल नोदक पर आधारित चरण है, इसका प्रज्वलन शुरू हो चुका है और वर्तमान में प्रणोद उत्पन्न कर रहा है।
The launch vehicle is at an altitude of 73 kilometers. First stage has been separated. Second stage has begun its operation and the closed loop guidance has been initiated. According to the announcement by Range Operations Director, PS2 is developing nominal thrust.
PS2 41 टन के तरल नोदक पर आधारित चरण है। इसमें विकास इंजन द्वारा 800 किलो न्यूटन का प्रणोद उत्पन्न होता है और इसका प्रज्वलन काल लगभग 150 सेकंड का होगा।
SHAR and Port Blair tracking stations presently acquiring signals. Flight path closely matching the prediction.
+3 minutes.
वर्तमान में यान क्लोज लूप गाइडेंस के अंतर्गत है।
Second stage performance normal.
यान की ऊंचाई 106 किलोमीटर तथा सापेक्ष गति 3 किलोमीटर प्रति सेकंड।
The velocity addition in PS2 regime is going to be from 2 kilometers per second to 4.9 kilometers per second.
Payload fairing separated.
The payload fairing covering the Aditya L1 spacecraft has been separated. The current altitude of the launch vehicle is 118 kilometers. Relative velocity exceeding 3.8 kilometers per second.
जी हाँ, यान अब घने वातावरण से बाहर जा चुका है, इसलिए ऊष्मा कवच की जरूरत नहीं रह जाती है और इस कारण इसे यान से पृथक कर दिया जाता है।
Second stage performance normal.
द्वितीय चरण वर्तमान में प्रणोद उत्पन्न करता हुआ और यान पूरी तरह सामान्य प्रदर्शन करता हुआ अपने अनुमानित पथ की ओर बढ़ रहा है।
Second stage separated, third stage ignited.
द्वितीय चरण को भी सफलतापूर्वक यान से पृथक कर दिया गया है उसके प्रज्वलन काल समाप्त होने पर। और तृतीय चरण जो कि ठोस नोदक पर आधारित चरण है, इसका प्रज्वलन शुरू हो चुका है।
We are close to 5 minutes past the launch time. Presently, the third stage of PSLV is operational, developing nominal thrust.
Plus 5 minutes.
तृतीय चरण में 117.7 सेकंड का होगा। इस दौरान यह 240 किलो न्यूटन का प्रणोद उत्पन्न करेगा। वर्तमान में यान की ऊंचाई 134 किलोमीटर तथा सापेक्ष गति 5.96 किलोमीटर प्रति सेकंड। जैसा कि हम जानते हैं PSLV सबसे विश्वसनीय रॉकेट रहा है इसरो का, वैसा ही प्रदर्शन करता हुआ एक और मिशन PSLV C57 का।
For the present mission, after PS3 completes its burn duration, a coast phase of 200 seconds will continue to be steered while there is no development of thrust.
जी हाँ, अभी कुछ ही क्षणों में PS3 का प्रज्वलन काल समाप्त हो चुका है और कोस्टिंग फेज इसके बाद जारी रहेगा।
Vehicle in combined hosting for approximately 200 seconds.
Unique to this mission, the PS4 will start twice at pre-designated times and duration. The multiple start capability of PS4 will be utilized very aptly to achieve the argument of perigee of 346.6 degrees, which is very crucial for this mission. The commencement and duration of PS4 burns enable achieving this orbital parameter. Argument of perigee is the angle that is made by the perigee point from the ascending node at equatorial plane. AOP exceeding 300 degrees is helpful in mission planning to achieve halo orbit around L1 with minimal propellant expenditure.
सभी वैज्ञानिक गहनता से अध्ययन करते हुए इन आंकड़ों का जो कि ग्राउंड स्टेशन द्वारा प्रसारित किए जा रहे हैं। वर्तमान में PS3, PS4 कंबाइंड कोस्टिंग फेज जारी है। यान की ऊंचाई 170 किलोमीटर तथा सापेक्ष गति 7.32 किलोमीटर प्रति सेकंड है।
performance normal.
Plus 9 minutes.
Speaking a few words about the Aditya L1, describing the sun, Indian Vedas have said, Yesha Bhagavan Manirakasha Mandalasya Chakravati Khechara Chakrasya Deepako Brahmanda Bhandasya Asayeva Charkarti Bharvati Jarhati Jagat. This mighty jewel, the light of eastern sky, who generates, operates and destroys the universe, while the energy of sun, after having filtered by the atmosphere, is available for the sustenance of earth, the explosive phenomena in sun and the solar flares are a cause for concern to the spacecraft and human space missions. The vantage point for such observations is a place in between the sun and earth.
Third stage separated.
Now we have a successful separation event of the third stage of
Separated
PSLV.
hosting. It is approximately 900 seconds.
Plus 10 minutes.
जी हाँ, तृतीय चरण को सफलतापूर्वक पृथक कर दिया गया है और अब PS4 कोस्टिंग फेज पर है। इस दौरान कोई भी प्रणोद उत्पन्न नहीं हो रहा है। यान प्राप्त संवेग से आगे बढ़ता हुआ और निर्धारित पथ का अनुकरण करता हुआ जा रहा है।
We are 627 seconds from the launch. For another 600 more seconds or so, we will be getting tracking data from the BIAX ground station.
यह कोस्टिंग फेज लगभग 900 सेकंड का होगा। इस दौरान हम आपको कुछ जानकारी देते हैं। लैग्रेंज पॉइंट से जुड़ी कुछ रोचक तथ्य भी हैं, जैसे कि इस पॉइंट का नाम एक इटालियन फ्रेंच गणितज्ञ जोसेफ लुइग लैग्रेंज के सम्मान में रखा गया था। उन्होंने 1972 में इसे अपनी तकनीकी प्रपत्र जनरल 3 बॉडी प्रॉब्लम में वर्णित किया है, लेकिन इससे पहले भी 3 पॉइंट L1, L2 और L3 को खोजने का श्रेय स्विस गणितज्ञ लियोनार्ड आयलर को जाता है। L1 पॉइंट पर नासा ने पहले ही सोलर एंड हेलियोस्फेरिक ऑब्जर्वेटरी सोहो को पहुंचा चुका है और विश्व प्रसिद्ध जेम्स वेब टेलीस्कोप को L2 लैग्रेंज पॉइंट पर स्थापित किया गया है। L1 की पृथ्वी से सूर्य की दिशा में दूरी लगभग 15 लाख किलोमीटर है और इसे हम एस्ट्रोनॉमिकल यूनिट में 0.01 एस्ट्रोनॉमिकल यूनिट कह सकते हैं। यह पृथ्वी से सूरज की दूरी का केवल 1% है।
The vantage point for observing sun is a place in between the sun and earth where direct visibility exists to the sun while continuous communication link exists with the earth. These observations will generate a forewarning about disturbances in near Earth space environment which could pose danger to the communication systems and spacecrafts. Various thermal and magnetic phenomena on the sun are of extreme nature which cannot be replicated in labs. The best way is to observe the sun up close. The distance between the Earth and Sun is approximately 150 million kilometers. At the central region of the Sun, known as core, the temperature can reach as high as 15 million degrees Celsius. Power source for the Sun is nuclear fusion of hydrogen atoms that takes place in the core. The visible surface of Sun is relatively cool and has a temperature of about 5,500 degrees Celsius. The Aditya L1 spacecraft is planned to be placed in a halo orbit around the Lagrangian point 1 or L1 of the Sun-Earth system, which is about 1.5 million kilometers from Earth, roughly 1% of the distance to Sun. A halo orbit is a periodic three-dimensional orbit near the Lagrange's point in the three-body problem of orbital mechanism. The object in this orbit stays in place by the gravity of Earth and Sun. It requires little energy for station keeping. Several probes have been placed in space to observe the Sun by various space agencies. Lagrange's point L1 is a great location for solar explorers such as Aditya L1, as it allows for an unobstructed view of the Sun that is never eclipsed by Earth. At L1, Aditya L1 will join spacecraft such as ESA-NASA's Solar Heliospheric Observatory or SOHO, which has been at L1 since 1996.
लैग्रांज पॉइंट एक ऐसी जगह है अंतरिक्ष में जहां अगर कोई चीज़ पहुंचती है तो वह वहीं बनी रहती है, क्योंकि लैग्रांज पॉइंट पर दो बड़े द्रव्यमानों का गुरुत्वाकर्षण खिंचाव बराबर हो जाता है और इसमें एक अभिकेंद्रीय बल है कि जो कि पिंड को दोनों द्रव्यमान के साथ बनाए रखता है। ऐसे 5 लैग्रेंजियन पॉइंट्स होते हैं पृथ्वी और सूर्य के बीच। इन पॉइंट्स में अंतरिक्ष यान को भेजकर कम से कम ईंधन की खपत पर या उस स्थान पर अंतरिक्ष प्रयोगों को अध्ययन के लिए बनाए रखा जा सकता है। आदित्य L1 उपग्रह को भी ऐसे ही लैग्रांज पॉइंट 1 पर स्थापित किया जा रहा है। अंतरिक्ष यान को यहां तक पहुंचने में 125 दिन का समय लगेगा। इस लैग्रेंजियन पॉइंट्स के कुछ फ़ायदे होते हैं, जैसे हम यहाँ आदित्य L1 के बारे में बात कर रहे हैं तो यह अंतरिक्ष यान लैग्रेंजियन पॉइंट 1 के पास जाएगा और यहाँ ऐसा पॉइंट है जहाँ से सूर्य को बिना किसी ग्रहण या रुकावट के निरंतर देखा जा सकेगा और अध्ययन किया जा सकेगा। दूसरा फायदा यह कि विभिन्न मापन या विश्लेषणों के लिए किसी भी तरह की रुकावट या कमी नहीं आएगी। वायु न होने की वजह से इससे दूर तक स्पष्ट देखा जा सकेगा। लैग्रेंज पॉइंट पर इस वेधशाला को रखने का मुख्य कारण यह भी है कि यहाँ उपग्रह लगभग स्थिर रहेगा और उपग्रह के अभिवृद्धि नियंत्रण के लिए अधिक ईंधन की आवश्यकता नहीं होगी। वर्तमान में PS4 चरण का कोस्टिंग फेज जारी है। अब यान की ऊंचाई 280 किलोमीटर तथा सापेक्ष गति 7.18 किलोमीटर प्रति सेकंड है। अब यह उचित अभिवृद्धि प्राप्त कर पुनः प्रज्वलित किया जाएगा।
Vehicle performance normal.
The Aditya L1 spacecraft carries 7 payloads to observe the protosphere, chromosphere and corona, which is the outermost layer of the Sun. These payloads use electromagnetic, particle and magnetic field detectors. First among the 4 remote sensing payloads is Visible Emission Line Chronograph, VELC, which is a prime payload designed as a reflective coronagraph with a multislit spectrograph. This payload is developed jointly by Indian Institute of Astrophysics, Laboratory of Electro-Optical Systems, UR Rao Satellite Center, ISRO Inertial Systems Unit and Space Applications Center. The second payload is Solar Low Energy X-ray Spectrometer or SOLEX, designed to measure the solar soft X-ray flux to study solar flares. This payload is developed by UR Rao Satellite Center. Third payload is the Solar Earth Ultraviolet Imaging Telescope SUIT, which is a UV telescope to image the solar disk in the near ultraviolet wavelength range. The payload is developed by Inter-University Center for Astronomy and Astrophysics, Pune, LEOS, URSE and IISU. The fourth payload is High Energy L1 Orbiting X-ray Spectrometer or HELIOS, developed by URSE is a hard X-ray spectrometer designed to study solar flares in high-energy X-rays. The fifth payload is the one which is meant for in-situ observations. This is Aditya Solar Wind Particle Experiment, or otherwise called as ASPEX, which comprises of spectrometers to measure low-energy particles and high-energy ions. This payload is developed by Physical Research Laboratory. The sixth payload is Plasma Analyzer Package for Aditya, in short PAPA. It is designed to understand the solar winds and its composition and perform mass analysis of solar winds. This payload is developed by VIKRAM-S Space Center. The seventh payload is a magnetometer or MAG developed by LEOS, which will measure the low intensity interplanetary magnetic field in space using a pair of magnetic sensors.
जी हाँ, आदित्य L1 उपग्रह में नितभार के बारे में जानते हुए इसमें सुदूर संवेदन नितभार हैं और यथास्थिति प्रेक्षण नितभार लगे हुए हैं। सुदूर संवेदन नितभार में सूर्य का प्रेक्षण करने के लिए VELC कोरोना प्रतिबिंबन और वर्णक्रम मापन के लिए है। सोलर अल्ट्रावायलेट इमेजिंग टेलीस्कोप जो कि संकीर्ण और ब्रॉडबैंड फ्रीक्वेंसी में फोटोस्फीयर और क्रोमोस्फीयर प्रतिबिंबन यह पैराबैगनी प्रतिबिंबन टेलीस्कोप है। इसी क्रम में अगला है SOLEX सोलर लो एनर्जी एक्सरे स्पेक्ट्रोमीटर जो कि सॉफ्ट एक्सरे वर्णक्रम मापी है जो कि सूर्य के प्रेक्षण के लिए प्रयोग किया जाएगा। इसमें HEL1OX हाई एनर्जी L1 ऑर्बिटिंग एक्सरे स्पेक्ट्रोमीटर है जो कि हार्ड एक्सरे वर्णक्रम मापी है। इसकी अभिकल्पना सोलर फ्लेयर के अध्ययन के लिए की गई है। यथास्थिति नितभार में आदित्य सोलर विंड पार्टिकल एक्सपेरिमेंट, इसका उद्देश्य है सोलर पवन सौर पवन में भारी आयंस, प्रोटॉन्स और अल्फा पार्टिकल का विश्लेषण करना। अगला है प्लाज्मा एनालाइजर पैकेज फॉर आदित्य। यह भी सौर पवन में उपस्थित कणों में इलेक्ट्रॉन और भारी आयंस की दिशा के साथ विश्लेषण करने के लिए इसे बनाया गया है। एडवांस ट्राइएक्सियल हाई रेजोल्यूशन डिजिटल मैग्नेटोमीटर, इसे त्रिअक्षीय चुंबकीय क्षेत्र के यथास्थिति मापन करने के लिए बनाया गया है और ऐसे 2 समुच्चय लगे हुए हैं इस उपग्रह में।
Vehicle performance normal.
यान पूरी तरह सामान्य, सभी तंत्र सामान्य रूप से कार्य कर रहे हैं और यान अपनी उद्देश्य कक्षा की ओर बढ़ रहा है। आदित्य L1 के नितभार इसरो व अन्य वैज्ञानिक संस्थानों के साथ मिलकर तैयार किए गए हैं। विजिबल एमिशन लाइन क्रोनोग्राफ VELC इंडियन इंस्टीट्यूट ऑफ एस्ट्रोफिजिक्स बेंगलुरु द्वारा तैयार किया गया है। सोलर अल्ट्रावायलेट इमेजिंग टेलीस्कोप सूट इंटर यूनिवर्सिटी सेंटर फॉर एस्ट्रोनॉमी एंड एस्ट्रोफिजिक्स पुणे द्वारा निर्मित है। सोलेक्स और हेलियोस दोनों ही UR सैटेलाइट सेंटर बेंगलुरु द्वारा निर्मित किए गए हैं। ASPX और PAPA स्पेस फिजिक्स लेबोरेटरी VSSC तिरुवनंतपुरम द्वारा निर्मित किए गए हैं। और अंत में मैग्नेटोमीटर लेबोरेटरी फॉर इलेक्ट्रो ऑप्टिक्स सिस्टम्स बेंगलुरु द्वारा निर्मित किया गया है। यह कोस्ट फेज जारी रहने वाला है। आइए इस अंतराल में आपको लिए चलते हैं इस मिशन से जुड़ी चर्चा में, जहां वरिष्ठ वैज्ञानिक हमारे प्रश्नों के उत्तर देंगे और फिर इस चर्चा के बाद हम वापस आएंगे लाइव इवेंट्स में।
As we are in the low visibility region of the flight path, we take you to the discussion room where the key personnel connected with the Aditya L1 will enlighten more on the payloads and details. Over to discussion room.
Welcome viewers. After India's made history with the Chandrayaan-3 moon launch, it has now set its eyes on the sun. These scientific breakthroughs back to back are like feathers on our country's hats. In fact, these celestial bodies are very important and are considered as sacred bodies in multiple global religions. The sun is the central body of our solar system. The world revolves around it, and it is a source of energy for all planets, including the Earth. Today, I am joined by all the scientists who have played behind the scenes to make this project a grand success. And I am Srinidhi, reaching out to you from the Satish Dhawan Space Center, Sriharikota. And today we'll be discussing about the impact and the benefits of the Aditya L1 space mission. So today we are joined by Dr. Anil Bharadwaj, Director of PRL, Professor Annapurni Subramanian, Director of Indian Institute of Astrophysics, Dr. Sankara Subramanian, Principal Scientist of Aditya L1 mission, Dr. Durgesh Tripathi, PI of SCYT, Dr. Dipankar Banerjee, Director of IRIS, Nainital, Dr. Satish Tampi, PI of PAPA, and Dr. Vipin K. Yadav, PI of Magnetometer, joining us today for a 25-minute fireside chat on the sidelines of Aditya L1 launch. To start with the Principal Scientist and PI of SOLEX, Dr. Sankara Subramaniam, why is Aditya L1 mission so important, and what are the objectives of this mission?
Thanks a lot. First of all, let me thank ISRO as well as the Government of India for providing a great opportunity for the solar and heliophysics community of the country. Both solar, heliophysics as well as astronomy thrives on data. More the data you have, we get more understanding about the system. And sun is our own star, our dearmost star, so understanding them is much more important for our everyday life. So this mission, Aditya, when it was conceived initially, with a support from our Professor U.R. Rao, along with Dr. Srikumar and Professor G. Srinivasan, we made sure that we will have a unique data set which is not available from any other missions internationally. So the 7 payloads what was conceived for this particular mission will provide a unique set of data which is currently not available from any other missions, which will provide us new insight into the solar and heliophysics community in India, and provides some important aspects like the initiation of the coronal mass ejections, the speed at which it gets initiated, and some wave bands which are very important for the Earth ionospheric connections like near ultraviolet band, and the high energy particles, which is high energy radiations as well as particles which is coming from the solar flares and coronal mass ejections. So these are the informations which would be available from this particular mission, which will allow us to understand the sun, its dynamics, as well as the inner heliosphere, which is an important element for the current day technology as well as the space weather aspects of it.
Thank you so much for your remarks, sir. So now we move on to Dr. Anil Bharadwaj. So the sun is a very important energy source of life. Having understood that, it creates a trouble when it's angry. How does Aditya L1 helps us through the mission?
Thank you and good morning, viewers. First of all, let me tell you that Aditya L1 is a multi-wavelength, multi-instrument and multi-directional mission. Multi-wavelength because it works in X-rays, UV and visible. Multi-instrument because there are 7 experiments on board. And multi-directional because it looks not only in the sun direction but also around it. Now when the sun becomes angry, there are 2 types of process which happens. One is solar flares, that means electromagnetic radiation, which reaches the earth in 8 minutes. But along with that, there is a mass which is also ejected out in form of plasma, and that can take about 2 to 4 days to reach the earth. What we are looking for from the Aditya L1 mission is to see the impact of solar flares as well as coronal mass ejections as they come to the Earth. We have instruments which look at not only in the sun direction, but also in other directions, for example, perpendicular to ecliptic or in the Earth directions. The impact is that we need to see when the sun becomes quite angry, what are the ways in which it is affecting the planet Earth, 1% away from the Earth. It is able to provide us a lot of new informations of the plasma and the electromagnetic radiations which is reaching the planet Earth.
Thank you so much, sir. So now we'll move on to Dr. Annapurni Subramaniam. So the science behind this mission is very unique. So what's the impact of this on the Earth and also on the heliosphere?
Yeah, so thank you for having me on this show. To put the thing in context, I'm the director of Indian Institute of Astrophysics, and we have delivered one of the major payloads on this mission. This is the visible emission line coronagraph. So if you actually look at the words used in it, it is visible because it is seeing the sun in the visible wavelength. Emission line, so what is it detecting? It is the emission line of certain elements. Because the corona is hot, the emission which you get is in the terms of, it's not absorbing the light which is coming from the sun, but it's already hot, so it is coming down by emitting lines. So we are tracking these lines using what? A coronagraph. Now what is a coronagraph? This instrument makes a total solar eclipse all the time within the instrument. So you are looking at the sun all the time, 24/7 through using this mission. And this instrument looks at the sun as though it is always in total solar eclipse. Now, why you want to have the eclipse all the time? Because you want to see the corona. Why corona? Because when sun burps, when sun is angry, the corona is what it takes the matter away. Now, what is unique about this instrument? This is going to see the corona as close as possible from the disk of the sun. Now, what is so challenging about it? It is because the sun's corona is 1,000,000 times fainter than the disk of the sun. So you have to not see the disk of the sun, but see only the corona. So this instrument is very difficult to make, challenging, but it is made. Now it's going to the orbit. Now what we planning to study using this instrument is the corona, its dynamics. Through this emission line, you can actually measure the velocity by simple physics called Doppler effect. So you can measure the velocity, you can measure how much matter is moving, and eventually how that matter will come to the Earth and the heliosphere. So it's overall this instrument, along with the others, of course, the other PI will also be explaining about it. So these holistically will give you a lot of information regarding not only the sun, but also the heliosphere. Thank you.
That was very interesting, Doctor. Thank you very much. And now we'll move on to Durgesh Tripathi, Dr. Durgesh Tripathi. You are the PI of the for the payload suit. How is that different from other telescopes like Hubble or James Webb? And what are you going to investigate using this?
Yeah, so good afternoon. My voice is going to mumble because I'm still in the awe of the launch and one of the payload is gone there. So essentially, JWST, which is James Webb Telescope, and the Hubble Telescope, they are going to look at the universe, different objects, galaxies, star formation, and other objects you see in the universe. Whereas when we talk about Aditya L1, it is going to look at one particular object, which is our sun. And it's also kept on the other side of the sun-Earth line at the L1 point, whereas the James Webb Telescope went on the other side of the Earth, which is at the L2 point. Now, the scientific difference, of course, they also observe in ultraviolet, but Aditya, as Professor Anil Bharadwaj and also Professor Annapurni Subramaniam alluded to, these are multi-wavelength satellite, and they will be observing all across the electromagnetic spectrum. In particular, suit is going to be looking at the ultraviolet radiation in 2000 to 4000 angstrom, if that matters to you, emits from the lower and the middle atmosphere of the sun. And what we want to look at that how in general the sun's atmosphere is coupled by looking at the observations at various height, and how actually this radiation is coming and getting absorbed in the Earth's atmosphere, and what kind of effect it can have in the chemistry of ozone and oxygen, for example, and also these explosions which are happening, how much radiation they are creating, and how much effect it might have. Thank you.
Thank you very much, sir. And now we move on to Dr. Satish Thampi. You are connected with the payload PAPA. Already the plasma particles on the moon are analyzed. How do you analyze plasma particles in the sun? And what is the importance of solar winds and how does it impact?
Thank you. Thank you for giving opportunity to come into this show. As my colleagues, they mentioned actually about the sun. Today we have the auspicious day where actually we are going to our own star, that is the sun. Just I want to tell to the viewers that actually the sun, which is our hero basically in the solar system. If you look into the mass of the solar system, 99% of the mass of the solar system is occupied by sun. And also this sun is plasma. Now when we are talking about the heliosphere, actually with this all our planets are engulfed in that thing. You know, we have been studying in decades, maybe in centuries, we have been studying about the sun. But what we are lacking actually a comprehensive approach because sun is giving its energy mainly in three forms. The first one is the radiation, actually my colleagues already talked about, which we can do remotely from our ground. But the plasma, basically we are talking about the solar wind, what we call the space plasma, as well as the magnetic field. This can be only studied by in situ. If we study all these radiation, particles and field, then only we will get a full comprehensive understanding of the sun. Now, we are getting the first space-based observatory from the Indian soil, and we are making this opportunity. And of course, I am thankful to ISRO and all my colleagues and my teammates from VSSC and all my scientific colleagues here. This is the opportunity we got actually, we are trying to understand actually all the three things, radiation, particles and field. Already they mentioned about the radiation, now Dr. Vivin will be talking about field. Just I want to emphasize on the particles. That's why we named it as PAPA. PAPA means Plasma Analyzer Package for Aditya. This is developed by Space Physics Laboratory in support of VIKRAM-S Space Center. And now this instrument has two components. If you look at the solar wind, basically it comprises of 95% protons, then alpha particles roughly around 4 to 5%, then equal number of electrons also. So our PAPA is a comprehensive package measuring both ions and the electrons. Now these electrons, like already our colleagues they mentioned actually the major transition events like coronal mass ejection. That's a huge mass which is coming out of sun. Basically it's a plasma. Basically when we are talking about solar wind, basically nothing but it's the extension of the corona only. That's the atmosphere. Now these particles actually they only actually modulate the energy and momentum of the planetary atmospheres. See when then sun is quiet, like it is not aggressive, suddenly what we are getting the ambient solar wind. So if you look into that thing actually, that one actually gives what we call it about the interactions, what we call the normal routine phenomenon which is happening on the earth. But when there is sun is angry, it gives like in a CME, CAR or these sort of events are happening, that is really going to affect our planets. That's what we call the space weather. Now our intention is to understand, first of all actually what these effects, basically the solar wind, in the ambient condition as well as during this transition events, how this solar wind behaves, and also how this coronal mass ejections which is passing through different planets, how actually, what are the different things, like what we call about the microphysics, macrophysics and the mesophysics of that things, that we want to understand. So one thing is actually it's a physics subjective to understand because we are getting an ideal point, Lagrangian point, which is in the sun-earth plane, and we will be seeing the events exactly there. Second thing is actually, we can definitely monitor the parameters. Like particularly Papa will measure the electrons and ions, we will be getting energy, direction and angular information, mass information. So if we know these things related to electrons we don't want the mass, but for the ions we are getting the mass information. Coupling all this information actually what we can do is we can derive the plasma moments. That will be definitely going to the modeling part, actually dynamics part, and that will definitely going to tell about the effect of the space weather effects. So in due course actually, with the L1 in addition to other L5 missions, we will be able to tell. This is the importance of the plasma missions. That actually, as you mentioned actually earlier with the lunar mission we achieved, we tried to understand that thing. Really it changed, this plasma studies changed the perspective. It will give more detail about it. Thank you.
Thank you, sir. Thank you so much for that, sir. And now we move on to Dr. Dipankar Banerjee. Beautiful solar observatory at Nainital. How do you think the studies of heliophysics will supplement Aditya L1? Can you tell us something about the history of solar observatories in India?
That's right. India has a long tradition of looking at the sun from the ground. In fact, from Kodaikanal Observatory, we have been observing the sun for more than 100 years. And also we have beautiful, solar observatory at Udaipur, in the lakeside, and at Nainital. We are looking at the sun. But there are limitations of looking at the sun from the ground because you can only see the lower atmosphere of the sun. So this was very, very important that we could go to the space. And this is a fantastic opportunity. Originally, more than 10 years back, we were only looking at a small satellite program. And then Professor U.R. Rao suddenly came up with this idea, why are we taking baby steps? We should think big. We should go to much longer distance. And then this opportunity came in, the Lagrangian 1 mission, The entire country, all the scientific institution got very much highly motivated. There are multiple payloads were then proposed. So eventually now we have a Lagrangian 1 observatory class mission. And as you heard from my colleagues, that it is a multi-wavelength observatory. So that's very important to have the shorter wavelength coverage from the space. And in addition, the ground-based observations are also important. So a combination of the ground-based telescope and the space-based platform is very, very important. And since you asked about the question about the, how Aditya in the overall heliophysics research within the international scenario, we only have 3 spacecraft around Lagrangian 1 point primarily from NASA and ESA. So I think again, this is a fantastic achievement from India. If you could reach L1 with the full observatory class mission, it will really open a new window altogether. So I think this is a great opportunity, and we are all looking forward. And as I mentioned, probably we'll request that, a better ground-based facility. We have already projected a National Large Solar Telescope project from the ground. I think this is now high time we have a very nice ground-based telescope also to complement the capabilities of Aditya L1.
Thank you very much, sir. Indeed, it's a very great opportunity. And now we move on to Dr. Vipin K. Yadav. So you're in charge of the magnetometer. What is the contribution of magnetometer to Aditya program?
You see, the magnetic field measurements are very crucial in space, and especially at L1 point. What we are going to measure with magnetometer is the interplanetary magnetic field that is coming all the way from Sun and towards the Earth. So typically these values at L1 point are around 5 to 10 nanotesla. But these values increases whenever there is an extreme solar event, such as the coronal mass ejection or say solar magnetic storms. Now these events are crucial to monitor the near Earth space weather, because these can have an effect on the life on Earth. If you remember Quebec, there was an event when the power lines were snapped a few years ago. That was because of an extreme solar event. So to keep an eye on the surroundings of Earth, we need these measurements, and apart from that, for solar wind observations also, these measurements will be crucial. Thank you.
Thank you very much, sir. So now we move on to Dr. Anuj Nandi. So what is the importance of solar flares and the impact in heliospheres, and how does Aditya L1 contribute to all of this?
Good afternoon, viewers. As my colleagues already pointed out the importance of this mission and the instruments about. So the thing is, as you know, that solar flares are the energetic and explosive energy release in few seconds to minutes time scale, and it is order of 10 to 27 arcs to 10 to 32 arcs. Now the thing is, these solar flares, why it is important, as because the solar flares actually tells the dynamics and activity in the sun. So the thing is, there are 2 unique instruments, our 200 keV. And we know that visible sun is only 6000 degree Kelvin temperature, whereas the outer surface of the sun is million degree Kelvin. So the thing is, why there is disparity? So I think these 2 instruments, along with the other 2 instruments, VLC and SUIT, we are going to address this $1 million questions, as well as why there is difference. Thank you.
Thank you very much, sir. And now I'd like to go back to Dr. Anil Bharadwaj. So there are many satellites that are sent to the space by other nations. So what makes Aditya L1 different from these satellites?
Well, that's a very good question, because first of all, let me again tell you that India will be the third, or ISRO will be the third space agency to have a mission at L1 point. And I just mentioned that it is multi-wavelength, multi-instrument, and multi-direction, and it measures particle, field, and radiations. So you don't have such kind of satellites existing at L1 point so far and currently. That makes Aditya L1 absolutely unique, because we are going to measure remotely, in situ, and particles and fields. I was also mentioning about multi-direction, and that is coming from the ASPEX payload, which stands for Aditya Solar Wind Particle Experiments. And this is going to measure particles ranging from 100 EVs going to several MeVs, which is essential for us to know, because when the CMEs are happening or the sun is quite angry, the plasma which is coming out from the sun ranges from several EVs to several MeVs. and therefore we should know in what direction the plasma is coming and whether the plasma is getting accelerated in between when it comes from sun towards earth, and therefore there is a multi-directional information which is available from the aspects payload because it consists of two sensors, Swiss and STEP, essentially giving you in two different energy bands, and therefore we'll be able to quantify the CME, CIRs, and all the processes which is happening on the sun, which gives out coronal mass ejections. Thank you.
Thank you very much, sir, for your remarks. And now finally we move on to the principal scientist, Dr. Sankar Subramaniam. So how does the Indian science community seek to capitalize on ISRO's space capabilities, especially these observatory missions like Astrostat and
There is a
Aditya
multi-directional information which is available from the aspects
so now,
payload.
ISRO has established that it has a capability to send observatory class missions anywhere in the interplanetary medium. ISRO also is developing capability for small satellite missions like a nanosat, CubeSat, as well as the small satellite capability. And that is something which especially a heliophysics community could utilize it, because we can at a low cost launch many more such instruments which are essential for heliophysics community here in India. So, and also as you know, the science and technologies are always synergized. As the technology improves, your science improves. When I started my career in solar physics, I started with a photospheric magnetic field. Now we are in a position where we can do coronal magnetic field with Aditya L1, which was not feasible when I was doing my PhD. So similarly, as we move on and as the technology starts to improve, we would be able to generate much more capable instruments, much more compact instruments, which will enable us to do much more science than what we can currently do. So we look forward to capitalize on ISRO's capabilities, both at the large scale as well as at the small scale instruments, and also its capability for developing new technologies in the near future.
Thank you very much, sir. That was very interesting. And to end this, I have a last question to Dr. Dipankar Banerjee. And it's about what kinds of outreach is possible through this launch to energize the scientific community?
This is a very, very important question, and we are proud to be Indian now after the Chandrayaan success. I think it's just not the students, it's the entire country is excited. And we got this opportunity to now travel towards sun. So it is very important that the younger generation, comes into the research and also utilizes the data. These scientific missions are for the community, and it has to be the community driven. So some of our scientists, who have been engaged with this mission for decades, we understand what is expected to be, this data. But the younger generation, they need to be trained. And so for that reason, we also have a Aditya support cell at Nainital, and we are going around in the country. We are regularly conducting workshops. So through these workshops and training program, we really want to reach out to other, people who are particularly in the universities or IITs, because they have so far not been directly involved with the Aditya mission. So I think we are really, really going out, and we expect that the youngsters, the next generation will come and utilize this data, because the data is for the community. So unless, we have more users, we will not be able to effectively utilize the data, scientific data which is coming, and the way we can help the community at large. Thank you.
Thank you very much, sir.
I think it is very important for us also to reach out to schools and colleges, because the younger generation should be told about this kind of activities which is happening in the country. Chandrayaan 3 launch has galvanized the whole nation, and everybody is interested to know what all is happening in the science and technology within the country. And therefore, this mission, along with the Chandrayaan 3 mission, that is the Aditya L1 mission and Chandrayaan 3 mission, is going to give us a lot of new information which is going to be very beneficial for the country. Thank you. Thank you very much.
Thank you everybody for participating in this discussion. And now we move on to the control room.
Thank you, Srinidhi. And I thank all the panelists for enlightening us about the high-tech science that Aditya L1 is about to do.
जी हाँ, अभी आपने सुना इसरो के तथा अन्य संस्थानों के वरिष्ठ वैज्ञानिकों ने हमारे बहुत महत्वपूर्ण सवालों के बहुत ही रोचक उत्तर दिए हैं। इस दौरान चतुर्थ चरण के बर्न 1 को कंफर्म किया गया है फिजी टेलीमेट्री स्थित स्टेशन से। इसमें यान में होने वाले त्वरण के बदलाव को मापा जाता है और इससे पता लगाया जाता है कि यान के इंजन में शुरुआत हुई थी या नहीं, और इसकी पुष्टि कर ली गई है। लेकिन अभी भी यान हमारे दृष्टि से बाहर है, हमारे ट्रैकिंग रेंज से बाहर है, लेकिन इसकी यात्रा अभी जारी है। और अब हम स्क्रीन पर देख पा रहे हैं यह पूर्वानुमानित पथ दिखाया जा रहा है। यह अनुमानित पथ है। ग्राउंड स्टेशन से पुष्टि होने के पश्चात यहाँ पर इसकी पुष्टि की जाएगी। आज 11:50 पर प्रमोचित हुए PSLV C-57 रॉकेट की यात्रा अभी भी जारी है। प्रथम, द्वितीय तथा तृतीय चरण के सामान्य कार्यकाल के पश्चात इन्हें यान से पृथक कर दिया गया था। और फिर
टर्मिनल acquires telemetry signal.
जी हाँ, इसकी पुष्टि हो गई है। शिपबोर्न टर्मिनल से हमारे यान को ट्रैक कर लिया गया है।
At present, ground trace and FPD are updated based on real-time data.
अब हमारे ग्राफ को वास्तविक समय से दिखाया जा रहा है। यह वास्तविक डेटा है जो अब हम देख पा रहे हैं।
Welcome back to the live coverage of PSLV C-57 Aditya L1 mission. The launch took place at 11:50 hours Indian Standard Time from the second launch pad at Satish Dhawan Space Center, SHAR, Sriharikota. The first, second and third stage of the launch vehicle have performed normally, and the launch vehicle was in the no visibility range for the ground tracking stations. Shipborne terminal in Pacific Ocean has started to acquire signal 51 minutes into the flight.
अब कुछ ही क्षणों में हम चतुर्थ चरण के पुनः प्रज्वलन को देखेंगे।
In the past 26 minutes or so, the ground trace for the flight was being updated by extrapolation.
Fourth stage engine started for band 2.
यहाँ अभी रेंज ऑपरेशन डायरेक्टर ने इसकी पुष्टि की। चतुर्थ चरण का प्रज्वलन शुरू हो चुका है। यह पुनः प्रज्वलन है PS4 का कोस्टिंग फेज के पश्चात। यह वास्तविक समय पे हमें यहाँ आंकड़े उपलब्ध हो रहे हैं क्रूज स्टेशन से।
Very happy piece of news here.
Normal.
Range Operations Director has confirmed the second burn commencement for the PS4 stage. Around 14 more minutes to go for the spacecraft injection.
जी हाँ, अभी भी लगभग 14 मिनट बाकी हैं हमारे अंतरिक्ष यान आदित्य L1 को अंतक्षेपण के लिए। आपकी जानकारी के लिए बता दें कि इस कालावधि जब अंतरिक्ष यान या हमारा यान हमारी दृष्टि से दूर हो जाता है, इस कालावधि में ग्राउंड स्टेशन की दृष्टि से बाहर जा चुका होता है और यान के ऑन बोर्ड कंप्यूटर पर टेलीमेट्री स्टोरेज पर यान के महत्वपूर्ण आंकड़े सेव किए जाते हैं। जब यह हमारे तय ग्राउंड स्टेशन की रेंज में आते हैं तब इन आंकड़ों का प्रसारण होता है और वहां से इनकी पुष्टि की जाती है कि यान इस दौरान किन गतिविधियों से गुजरा।
Fourth stage performance normal.
The fourth stage performing normally. The second burn is expected to last for 472 seconds.
यह चतुर्थ चरण है PSLV XL रॉकेट का। इसमें 2.5 टन के नोदक का इस्तेमाल हो रहा है। यह तरल नोदक हैं। इसमें 2 इंजन लगे होते हैं। हर एक 7.33 किलो न्यूटन का प्रणोद उत्पन्न करता है। इस तरह कुल प्रणोद 14.6 किलो न्यूटन का होता है।
Plus 55 minutes.
इस प्रज्वलन काल में इसे 472 सेकंड तक प्रज्वलित रखा जाएगा। वरिष्ठ गणमान्य व्यक्ति यहाँ उपस्थित हैं।
We are close to 55 minutes 30 seconds past the launch. PS4 stage currently burning for the second time.
Fourth stage performance normal.
Intended trajectory closely matching the prediction. Presently, the shipborne terminal is acquiring the signal. Few seconds later, there will be another no visibility phase before Koru starts to acquire signal.
जी अभी द्वितीय बर्न चालू है PS4 स्टेज का। अभी कुछ 200 और सेकेंड जलकर यह शांत हो जाएगा। सूर्य एक बड़ा और हमेशा से एक समीप का सितारा रहा है हमारे लिए। असल में यह गर्म आग का गोला है जो अनगिनत हाइड्रोजन एटम्स के फ्यूजन रिएक्शन से ऊर्जा प्राप्त करता है और इस ऊर्जा से इस सौर मंडल को एक परिवार की भांति समेटे हुए है। पृथ्वी से सूर्य की दूरी लगभग 150 मिलियन किलोमीटर है। सूर्य ही हमारी ऊर्जा स्रोत है और इस जीवन जो हम जानते हैं उसका भी स्रोत है।
Loss of signal for shipborne terminal. The next telemetry station is Kuru. The telemetry signal break will be approximately 205 seconds. During this non-visibility period, ground trace and flight parameters will not be updated.
यान फिर से अंतर्दृष्टि हो चुका है, हमारे ट्रैकिंग रेंज से बाहर है। अगला ट्रैकिंग स्टेशन कुरू स्थित फ्रेंच गयाना स्थित कुरू स्टेशन से हमें आंकड़े उपलब्ध होंगे कुछ ही समय में।
After being injected into the space, the Aditya L1 will not travel directly to the L1 point. Transfer maneuvers will be performed to position the spacecraft in a halo orbit. Aditya L1 will first be made to perform maneuvers in Earth orbit. Adjustments will be made in its orbital parameters. After ascertaining the normalcy of the craft, its systems, payloads, and the orbital parameters, burn to exit Earth's sphere of influence will be initiated. After exit from SOI, the cruise phase will start and subsequently the spacecraft will be injected into a large halo orbit along L1. The total travel time from launch to L1 will take about 4 months for Aditya L1.
इस दौरान आइए आपको अवगत करा दें आदित्य L1 के मुख्य उद्देश्य से। आदित्य L1 मिशन का मुख्य उद्देश्य है सौर गतिविधियों के विभिन्न पहलुओं में महत्वपूर्ण जानकारियां उपलब्ध कराना और इन गतिविधियों का अंतरिक्ष मौसम के असर का अध्ययन करना। इस कार्य के लिए इसमें 7 निभार लगे हुए हैं जिनकी मदद से आदित्य L1 फोटोस्फीयर, क्रोमोस्फीयर और सूर्य के बाहरी परत के विभिन्न वेवलेंथ में प्रेक्षण कर सकेगा। विशेष वैज्ञानिक उद्देश्य इस प्रकार हैं: सूर्य के ऊपरी परत जिसे हम कोरोना के नाम से जानते हैं, इसकी गतिकी का अध्ययन करना, क्रोमोस्फीयर और कोरोनल तापमान, आंशिक रूप से आयनिक प्लाज्मा की भौतिकी, कोरोनल मास इजेक्शन की शुरुआत और फ्लेयर्स का अध्ययन, सूर्य के कण की गतिशीलता के अध्ययन के लिए मापे प्रदान करना और यथास्थिति कण और प्लाज्मा वातावरण के प्रेक्षण करना।
+1 hour.
वर्तमान में आरओडी ने घोषणा की अब चतुर्थ चरण को बंद कर दिया गया है, अब उसका थ्रस्ट कट ऑफ कर दिया गया है और वह बंद हो चुका है और इसकी भी पुष्टि हो चुकी है कि आदित्य L1 के अंतःक्षेपण की स्थितियां प्राप्त की जा चुकी हैं।
We are now eagerly awaiting the injection of the satellite as we have the confirmation from the Range Operations Director that the thrust cutoff for 4th stage of PSLV has been achieved. We are 1 hour into the flight.
कुछ ही क्षणों में कुरु स्थित ग्राउंड स्टेशन से इसकी पुष्टि की जाएगी।
Highly anticipated event next is the separation event of Aditya L1 spacecraft.
यान अपने निर्धारित कक्षा की ओर कुछ ही क्षणों में इसकी पुष्टि होनी बाकी है। यान से अंतरिक्ष यान आदित्य L1 का सफलतापूर्ण अंतःक्षेपण अभी बाकी है।
For Aditya L1, ISRO has developed advanced flight dynamic software to obtain past trajectory data from tracking, apply mathematical computation to calculate present and future location of the spacecraft in a process known as orbit determination. But the correct orbital parameters at the time of injection are of prime importance.
अब तक कुल 22 सौर मिशनों को नासा, ईसा, जर्मन
Aditya L1 satellite separated.
और जिसका इंतजार था वह पल आ चुका है, इसकी पुष्टि कर दी गई है। आदित्य L1
Aditya L1 mission accomplished Handing over to Mission Director.
And we have a confirmation of Aditya L1 separation. The mission has been accomplished.
PSLV C57 has injected Aditya L1 satellite into the desired intermediate orbit. PSLV C57 Aditya L1 mission is accomplished.
आदित्य L1 को पूर्ण परिशुद्धता से उसके निर्धारित कक्षा में स्थापित कर दिया गया है। इसके बाद वह अपने आगे की सफर जारी रखेगा L1 पॉइंट के लिए।
Do join us for the address by Chairman ISRO Secretary Department of Space Shri S. Somnath.
सभी दर्शकों को शुभकामनाएं और बधाइयां इस मिशन की सफलता के लिए। अब हम आपको लिए चलते हैं अध्यक्ष महोदय के एड्रेसिंग के लिए।
Congratulations. The Aditya L1 spacecraft has been injected in an elliptical orbit of 235 by 19,500 kilometers, which is intended very precisely by the PSLV, very unique mission mode here, with the upper stage of the PSLV taking 2 burn sequence for injecting the primary satellite for the first time. So I want to congratulate PSLV for such a very different mission approach today to do this mission of Aditya L1 to put it in the right orbit. Now, from now, the Aditya L1 will take its journey after some Earth maneuvers. It will start its journey to the L1 point, a very long journey of almost 125 days. So let us wish all the very best to Aditya spacecraft for its long journey and being put around the halo orbit of L1. So with me, the mission executives are there. Mr. Biju, the mission director, and Nigar Shahji, the director of the satellite project. So let them join me. Our Honorable Minister of State for Science, Technology and Space is here, Dr. Jitendra Singh. So I request him to speak a few words.
Congratulations, India. Congratulations, ISRO. And while the whole world watched this with bated breath, it is indeed a sunshine moment for India. Thank you, Honorable Prime Minister Narendra Modi ji, for making this happen by opening up new vistas for India's space sector and telling us that sky is not the limit. Thanks also, Honorable PM, for giving us the confidence, the courage and the conviction to reach out to the stars and to discover the mysteries of universe beyond. And thanks also for making us realize the enormous potential of our space fraternity. Ladies and gentlemen, Indian scientists had been working, toiling day and night for years and years together, but now comes the moment of vindication, the moment of redeeming the pledge to the nation. And coming close on the heels of successful Chandrayaan-3 landing, the successful launch of Aditya L1 is also a testimony to the whole of science and a whole of nation approach which we have sought to adopt in our work culture. While ISRO is credited in executing this mission, the science institutes across the country have come forward to contribute in one form or the other, in small measure or big, to this mission. To name a few, the Indian Institute of Astrophysics, Bengaluru, the National Aerospace Laboratories, the Tata Institute of Fundamental Research, Mumbai, the Nijri NGRI, Nagpur, the IIT Kharagpur, IIT Madras, IIT Delhi, IIT Mumbai, and the list is too long. But that, having said that, gives me the confidence to say that this day, the 2nd of September 2023, is a day of reckoning when we move on into the next 25 years of Amrit Kal, and Mother India pledges with the collective will and collective effort of our 140 crore children to reach and occupy the place of pride on the world pedestal. Congratulations once again, Chairman Somanath, the entire ISRO team, and the entire countrymen.
May I request the Project Director of Aditya L1, Nigar Shaji, to say a few words.
Good afternoon. It's a dream come true for Team Aditya L1, and I'm extremely happy that Aditya L1 is injected in the intended orbit flawlessly by PSLV as always. And Aditya L1 solar panels are deployed, and the spacecraft will be normal. And Aditya L1 has started its 125 days of long journey towards L1. We have our Earth burns to rise the orbit, and followed by the trans L1 injection, and finally insertion into the halo orbit in the Sun Earth Lagrange point L1. Once the Aditya is commissioned, it will be an asset to the heliophysics of the country and even to the global scientific fraternity. And I take this opportunity to thank Chairman ISRO, Director URSC, former Director URSC, and all the center directors for their support and guidance for making this mission possible. And my thanks are due to my project team and all the project executives across the center, payload teams, especially the teams from the IAA and IUCA, for the relentless effort in building the payload as well as the spacecraft. And my special thanks to the expert committee who have been guiding all through the entire project life cycle. And I thank all the industrial partners and the entire URSC team for their invaluable contribution. And I feel really honored and privileged to be part of this mission. And at this juncture, I would like to remember Professor U.R. Rao, who sowed the seed for this mission, and looking forward for a successful halo orbit insertion and further great science output from the Aditya L1 mission. Thank you all.
Sri Biju, the Mission Director and the Project Director of PSLV.
Good afternoon to all. My big salute to all of you for achieving this wonderful mission of Aditya. We have injected Aditya in its intermediate orbit. PSLV in its 59th mission has successfully accomplished injecting Aditya L1 in its intermediate orbit. It's all because of the dedicated effort of all of you. The challenging requirements given by satellite team was it was very challenging to meet the orbital requirements. We have gone for a new mission design strategy. We have gone through numerous simulations to validate this, and that is the proof that you are having now. I take this opportunity to thank each and every one of you for achieving this wonderful mission. I take this opportunity to thank all my review forums, chairman and members of all review forums, and our industry partners for giving high reliable systems for PSLV, and all our family members. With this, our capability of PSLV has increased manifold to venture into new missions, to new and challenging missions. I take this opportunity to thank my project team led by our Sri M.J. Lal as well as Damodaran, Vehicle Director and Associate Vehicle Director, in leading the entire campaign. I wish our satellite team an excellent time ahead for completing all the operations and completing all scientific objectives they have envisaged. Thank you all. Thank you very much.
Thank you everybody for spending your time watching this mission and also supporting us and congratulating us, and we joined the entire country. We are very proud of the fact that we could do this mission, Aditya L1 mission, just following the Chandrayaan 3 activities, and all of you are aware that the lander and the rover are still functioning, and our team is with the scientific instruments doing a lot of work now. And the good news is that the rover has moved almost 100 meters from the lander, and we are going to start the process of making both of them sleep in the coming 1 or 2 days, because it has to withstand the night. So until we hear about them later, so I would like to say big thanks to each one of you for the support and encouragement and blessings that you are giving to us for continuing the work of building the very strong space infrastructure and capability for India, and which will be becoming one of the strong pillars of science and technology for this nation. And thank you so much for the contributions once again, and wish you all the best for meeting you for next mission from Satish Dhawan Space Center. Thank you. Contribution from across the center, this could be done. So let me start with the Director VSSC.
Good afternoon, India. So this is the 59th mission of PSLV, and 1993 was the first mission. So this is the 30th year of PSLV. So it's PSLV is on the threshold of Shashti Purti. With the next launch, it will be crossing, will be making 60th launch. I wish all the very best to the satellite team, all payload specialists for the operation of the payloads and satellite in coming days. And I'm take this opportunity.
Presentation, we request you to please take your seat here in front, and thereafter Space Angel Australia and SABR in Australia. The presentations will be made, ladies and gentlemen, from this podium. We also have a clicker for your convenience. The clicker, the slide changer, as you can see, has a green button, which is to go ahead on your slides, and the red button is to go back, should you skip a slide. And the other thing that I have to announce is each presenter is going to get 3 minutes. We request you to please stay within time limit, and a buzzer will be sounded at the end of 2 minutes 30 seconds. So that will alert you when you have 30 seconds remaining. Additionally, there's going to be a timer running on the topmost right corner of your screen for you to assess time. are going to be with the console, but I'll
So they have it.
I'm sure they'll have it. If you've submitted them, they'll have it.
Okay.
You've already given them, right? Because yours is the fourth one.
Okay.
I mean, this sixth actually, because first we have industry bodies.
Okay. Hello.
Ladies and gentlemen, we are now starting with the Space Business Connect session. In this session, we have actually invited overseas and Indian companies to make a pitch about their companies. We have a total of 49 companies as well as 2 industry associations whose representatives are going to be making a pitch presentation. As I said earlier, we request each speaker to be brief and complete their talk in under 3 minutes. Before we begin with the pitch presentation session, we'd like to extend a very warm welcome to Dr. Pavan Goenka, Chairman InSpace, who's going to be chairing this session. We extend a very warm welcome to Mr. Somnath S., Secretary, Department of Space and Chairman ISRO, seated on the head dais. And we also extend a very warm welcome, ladies and gentlemen, to Dr. Vinod Kumar, Director Promotion InSpace, and Mr. Shantanu Bhattavdekar, who's the Scientific Secretary of Indian Space Research Organization. Let's extend a hand and welcome the dignitaries in our midst. And I extend a very warm welcome to all the distinguished delegates. And ladies and gentlemen, with that, I would first, of course, request Dr. Pavan Goenka, Chairman InSpace, to do the opening remarks. Can we have the microphone on, switched on the dais, please?
Good afternoon, everyone. Secretaries, DOS, and my other colleagues here. Welcome to the grand finale of a hectic 2 days of schedule. And as was mentioned by Swarya, that we have about 50 people who will be presenting their pitch on their company. And this will be a Guinness Book of World Record probably for 50 people to finish their talk in 2.5 hours. And that too engineers and scientists and business people. So no politicians though. So so let's see how we manage that. But let me just say it's in a way continuation of what we talked about in the morning, where we talked about what each country is doing, and now we are talking about what some of the companies are doing. We have a very good lineup of companies that will be making the presentations. And I think you will find, as I looked at some of the presentations, that fair amount of work is happening all over the world, something that none of us perhaps have a full view of. And when we go through this impressive presentation, we will really realize that
private sector has come of age when it comes to the space sector. I'm going to request my colleague, Dr. Vinod Kumar, who is Promotion Director in space, to make an opening statement, and then we will start the presentations.
Thank you, sir. Respected Sri Somnathji, Secretary Department of Space, and Dr. Pawan Goenka, Chairman in Space. Ladies and gentlemen, very good afternoon. On behalf of G20 SELM Organizing Committee, I extend a warm welcome to all of you to this amazing Space Business Connect session. During this session, these presentations are planned by global space industry. It is indeed a very significant day as we gather here to witness the cutting-edge innovation and capabilities of space industries from around the world. Friends, we are witnessing a new space era in human history where the space industries are working to revolutionize our understanding of the universe. I am honored to be here before you all as we embark on this journey that we shape the future of space explorations. It is truly inspiring to witness the incredible growth and potential of the global and Indian space industry. The blossoming Indian space industry has garnered worldwide attention and admiration in recent times. You should have read a recent article in New York Times, Explosive Growth of Indian Space Tech Startups. I am pleased to see that out of total 50 plus presentations, over 60% are from Indian industry. Your dedication, ingenuity, and relentless pursuit of excellence have positioned Indian space sector to be reckoned with within the global space community. Friends, the space industry with its ever-expanding opportunities has the power to transform not only the understanding of our universe, but also everyday lives of here on the earth. Under various verticals of space, I would like to express my gratitude to the G20 SELM Organizing Committee for this initiative. Your commitment to nurturing the space ecosystem is commendable, and we are privileged to have your unwavering support. The potential partnership that can develop here can propel your ventures to new heights. Without further ado, let us embark on this remarkable journey of limitless possibilities. Friends, new space era has begun. Thank you, and let the presentation begin. Please stick to the allotted time as we have to have presentation from 50 plus presentation. Thank you.
Thank you very much, sir. And with that, ladies and gentlemen, we will first start with the presentations from the industry bodies. So I'm going to request Mr. Anil Kumar Bhatt, Director General of ISPA, Indian Space Association, to please make his presentation. Sir.
Good afternoon and Jai Hind. Chairman ISRO, Chairman in Space, dignitaries on the stage, and industry delegates in the Space Economy Leaders Meeting. It's my honor to represent the Indian space industry here, and I will quickly go through some of that has been spoken in the last 2 days, would be a repetition. Please pardon me for that, but I would skip most wherever that is required. The Indian Space Association was made in October 2021 to create an enabling environment for strengthening the private industry in the Indian space sector and to propel India to the global forefront in the entire space ecosystem. And our focus areas were, of course, most importantly, unified for the policy framework, for energizing business growth, to interface with the defense and security agencies in India, for capacity and knowledge building, and for international partnerships. During our inauguration, these are the 4 frameworks the Prime Minister gave us. The first was allow the private sector freedom of innovation. Government to play the role of an enabler. We have to prepare the next generation for the future in space and treat the space sector as a resource for the progress of the common man. We today have these members I am flashing to you to just flash to you the major industry players in space which are there in India. 7 of our founding members, 9 of our core members, all of these have been suppliers of components or vendors to ISRO. And now we are looking at them to evolve as independent entities to do end-to-end work in space. We have associated members also, which are also some of them international companies, and we have a large number of startups. Putting them as per their expertise, this is how the upstream, midstream, and downstream looks in India. This slide was flashed yesterday by the chairman of InSpace. What I wanted to add is from September last year, when the draft telecommunication policy was taken out, and thereafter the draft geospatial policy, and in April this year, the release of the space policy, these have been very important events in the growth of the Indian space sector. And we are awaiting the FDI policy, which we are hopeful will be coming very soon. Notwithstanding that, activities by our industry members have already started in India. This is how the startups have grown today, with a total about 148 which are there recorded, and much more who have registered themselves with InSpace. The chairman ISRO, in one of his talks 6 months back, coined a new word called the National Space Enterprise of India. And what he said was, beyond ISRO, now it is NSIL, InSpace, the entire Indian Space Association, and the entire Indian space industry, that includes startups and academia. And all these, which form the space enterprise, would lead India's future space journey. Of course, many of our industry members will be supported and handheld by ISRO, which has a legacy of more than 60 years. Move the next slide, please. We have had a very positive indication even before the government had announced the policy in 2020, and this is the kind of investment which our startups received in India. And every year it has been increasing, and in 2023, we are very confident that it will cross the figures which are there for 2022. Some of this was again flashed by my chairman, but I would like to highlight to you some of the major activities which has happened is, of course, firstly is the signing of the contract for the PSLVs, 5 PSLVs, with HAL and L&T consortium. Then is Skyroot, which was a startup which just came up in 2018 and was able to launch in November 15, 2021. Agnikul is another company which is making a 3D printed semi-cryogenic engine which has been tested on ground, and we hope they would be launching very soon this year. We had a historical launch of 72 satellites in 2 launches for OneWeb, which happened last year and this year in April. Digantara, again a startup, has successfully launched the world's first commercial space-based weather monitoring systems. Pixel has been able to launch 3 satellites and has also got a contract from NRO in USA. Dhruva has launched 2 nano satellites, while Nelco and Telesat are successfully have had a demo on LEO in India. Ajista, just in June, on 10th June, has launched their first satellite. This is just some of the many successes we have had in the last 1 year after the new policy was announced. And in all this, hand-holding by ISRO and support from InSpace has been a very, very major and important factor in the growth of our private sector. These are the other activities which have happened. I'll not go through each one of them. We also got a very policy which I mentioned in April, which gives an opportunity to NGEs to do everything possible, be it in communication, remote sensing, navigation, and in all domains, including space mining and extraterrestrial activities. A lot of faith which has been put in non-government entities by the government, and I'm very sure that our industry will live up to these expectations. We have released certain documents. This document I just wanted to highlight. We had got, with ENY, we had got a study done last year on what is the overall Indian space economy compared to the world one, and the figures by their prediction by 2025, we would have an economy of about 13 billion. In various segments, the figures are given there. Of course, launch vehicles would be the least, about 1 billion. This is what the division of the sectors and the likely percentages growth which are likely to happen in satellite manufacture, launch services, ground segments, and satellite services. The largest growth, of course, would be in the launch services. We have also done a study. We had a meeting along with US and IIT Madras, where we were looking at the association of all space entrepreneurs in the Indo-Pacific. We all met there and we agreed that we would be making an association for all of us being together. On the aspect of space technology parks, many of our states in India have been moving in it. Kerala, Gujarat, Trivandrum, where at one spot they are providing all the opportunities for our space industry companies and especially the startups. We in ISPA carry out two conclaves. One is the Indian Space Conclave, which we started last year, and we had the minister and chairman ISRO there to support us, and a defense space symposium where we looked into what all the defense forces would require, all the three services, and we have been able to get 75 defense challenges for the industry from the Ministry of Defense. We would be having the next conclave from 4th to 6th October this year, and we would welcome all of you for that. I finish here. Thank you. Jai Hind.
Thank you very much, sir. And with that, we would once again reiterate the time limit. We have to stick to 3 minutes. Now I'd request Mr. Sanjay Kumar, President, Geospatial World, to kindly make his address.
Thank you very much and very good afternoon. Thank you to Dr. Somnath and Dr. Pawan for giving us this opportunity to talk about. I will be talking on behalf of the global geospatial community, a community which is more on to the downstream applications of space infrastructure, and my title would be more about space infrastructure and geospatial value for the world economy and society. Looking at what's happening around us is a lot of change which is on the rise is climate change, disasters, wasteland, or inflation. And the consequence of that is depleting agrofields, water scarcity, depleting natural resources, flora and fauna, and very important, depleting wealth of the nations. Especially in the last 3-4 years, a lot of wealth has gone away from us. So how do we deal with this situation? It's all about resilience and resilience of all kinds, be it economic, be it social, be it environmental, be it infrastructure, cultural, or human, diversity, equity. These are the kind of resilience the transition is going on currently around us. So, what is the role of space and geospatial infrastructure in that? Geospatial infrastructure and space help you measure, model, monitor, and manage what? And the output is in the form of productivity. It does help you increase productivity, efficiency, transparency, and compliance. And these are very important topics. And actually, when you talk about sustainability of everything, the compliance and transparency are equally important tool of sustainability of everything. And that's where the use of technology for productivity and efficiency is what leads to the economic growth, what leads to the sustainability of everything. Looking at geospace, the foundation of the digital economy. Geospace is actually the foundation. Today, we live in a digital age, and everything is dependent on geospatial technology and space infrastructure. What we help to do is describe the problem, diagnose the problem, predict the solutions, and then prescribe how to address that. This is the kind of workflow cycle we have to find hindsight, insight, and foresight. And that is how the economy is growing. That is how the businesses are using this technology across huge enterprises. You just say so many businesses are just dependent on the power of location, power of GNSS. PNT is inside every digital device of this world. And if the PNT is messed up, all of us are messed up. I'm telling about the economic impact. And what is that impact happening around us is that impact is transitioning our industry as a whole. The industry which was seen as a technology, the industry which was seen as a laboratory or a government function is an industry. So now you don't hesitate in saying that space is an industry or a geospatial is an industry in itself. And that is the kind of transaction taking place. And why this market map talks about is the fact that we have GIS and analytics, Earth observation, GNSS and positioning, frontier technologies, infrastructure modeling, solutions and system integrators, and the new kid on the block is the consulting firms. I can share these slides. I know it is not visible, but that is how the global geospatial and space market is organized. And look at the kind of companies, how they are playing into different parts of the role, and that's what we make a solution. And this slide, it talks about the $202 billion of investment in the last 3 years around geospatial and space. I heard about $100 billion investment, which has been said by various speakers in this summit. But where does other $102 billion comes in? That other $102 billion comes in actually from the location and geospatial investments. Host of investments is going on across the location companies, across the 3D modeling companies, across the indoor GIS companies, across the every aspect of living where we are making use of this technology. This industry is actually growing nowhere less than 17 to 20% CAGR every year. Just depends how do you want to define, how do you want to scope it up. That is what is the scope and definition is what makes you believe or not believe, or rather further believe. So global geospatial industry market currently is about $512 billion, out of which this includes GNSS and Earth observation as well. And let me tell you that 65 to 70% of this market is driven out of GNSS and Earth observation. And GNSS is almost 55% of that model. We give a lot of emphasis on Earth observation, but if you look at the actual uses of the space technology for the citizens or the consumers or the businesses or the security, GNSS is the driving force. GNSS is the driving force, I want to tell you. And this is growing at the stage of about 14%. I have a caveat to share. When somebody says that, geospatial space economy is about $1 trillion going to be in 2030, I actually disagree. Space economy right now is already $1.7 trillion. But depends on how do you want to define that. Do you take all the applications, which is Uber or Airbnb or Zomato or All those applications and their business values, do you take them into account as part of your economy? Yes. 35 billion deliveries have taken place in India in last 1 year. 35 billion deliveries means what? Every delivery is based on the location. Every delivery is based on the indoor map. Every delivery is based on the 3D modeling. That's what it is. And this is a published figure. We have just detailed exercise on this, and you have no hesitation in saying that this data is very, very correct. And the economic impact. Today itself, $7.5 trillion of economic impact. We as a profession, as a holistic profession, we make a $7.5 trillion economic impact. I'll just take 1 more minute or 30 seconds to say that why it is important that we actually talk about safety, sovereignty, and trade of space infrastructure. We heard about sustainability of space. We heard about the threats around that. If safety, sovereignty, and trade of space is not taken into account now, all this will be reversed. One bad actor, I already have seen, couple of bad actors can take it so backward that we all would be starting living into an age which we were about 20 years back. Thank you very much.
Ladies and gentlemen, I'm now going to request PT Pacific Satellite Nusantara, Indonesia, and to all the speakers, the presenters, I'd like to inform you once again now that we have a buzzer which is going to sound at the end of 2 minutes 30 seconds, and so that will alert you that you have 30 seconds remaining. You will also have on the top right of all screens the countdown timer running so that you're aware of time. Let me now invite PT Pacific Satellite Nusantara, Indonesia. Sir, you can also do it from here.
Before it starts, just for the knowledge of people from outside India, one of the areas where India has made significant opening up in this year is in the data availability. Geospatial policy was launched earlier the year, and space policy, and both have now made the space data very easily accessible to anyone and everyone, and there's no approval required of any kind for data below 30 centimeter resolution, or data less than 30 centimeter resolution.
Thank you very much for ladies and gentlemen for the time and for the head of delegation. We are from Pacific Satellite Nusantara. We are a private company in Indonesia. Actually is number 2 for satellite. Usually the number 1 is PT Telkom, is state-owned. But we are growing step by step. Okay, next one. Oh, sorry. So we already 32 years. 1991, PSN is being as a startup at the time. Then we are operating for the beginning as a incline orbit satellite because we don't have money. So we are, but we try to giving solution in the rural area with the motorized antenna and everything's underdeveloped by ourselves to make it incline as a business. And then the second, in 2000, we are together with Lockheed Martin is become MSS, Mobile Satellite Services, at the time as for L-band. And then 2009, we are one of the biggest become cellular backhaul for the GSM using satellite, at that time still using C-band. And 2016, we are complete MBO, means management by objective, means we are finished our financings, we changed our management. So then from that time, we have resources that to change all the platform of PSN. After that, 2019, we start Nusantara 1. This is the first HTS for Indonesia, even already have a IP star at that time. And then after that, 2020, we launched Nusantara 2 from this collaboration with China. 2019 is collaboration with SSL from US, thank you. And also in several weeks ago, we just launched the Satria 1, or we call Nusantara 3. It's a Satellite Republic Indonesia. This is the first collaboration with the government, 150 gigs. And then the next, we hope the second largest, 160 gigabits per second with Boeing. Okay, next. Oh, sorry. I back. This is our constellation. Nusantara 1, Nusantara 2, Nusantara 3, and Nusantara 5. And we hope, but Nusantara 2 is failed because of rocket. And then we hope by this year, our capacity will be 300 gigabit per second. And we are still designing another satellite. Our target by 2 years more is like 600 gigabit per second. This is our payload and capacity. Okay, enough, I think. Okay, finish. Basically, we are changed it to KA band from C band from KU. Then we change because the capacity not enough anymore. And then because I'm a head Secretary General for Satellite Association in Indonesia, Indonesia is growing like 65% only for the satellite. So satellite industry in Indonesia is a very high increase. Thank you very much.
Thank you very much, sir, for staying close to your time limit. Ladies and gentlemen, since we have over 50 presentations, I request you to please stick to time limits. We have to complete all the presentations. And I'm now going to request from Space Angel Australia, Mr. Ram Kuppuswamy, to join us on the podium. Also, I request all the industry body members, people at the back, to take front seats. The front seats are empty. We will take the country placards away very shortly, but we can always invite you to come and take these front seats. Sir, this is your clicker. The green button is for ahead and the red for the...
Good afternoon, ladies and gentlemen. Chairman of ISRO, Chairman in Space. I'd like to keep the presentation light. I know it's after lunch. Our project from Space Angel is the Australian Space Super Corridor. We are proud to build the world's first green spaceports. Our focus is to provide rapid rocket launches at a low cost from the green spaceport. The vision is to will be built together as a public-private partnership with the Western Australian government as well as the federal government in regards to providing access to space. Our project is currently listed on the WA Western Australian Investment government website at the moment, and you can get more information from that. The way we see our supply chain as well as collaboration, a close collaboration with India is very much how this looks like. In terms of shipping routes into Australia, Fremantle Port, which is pretty much Perth, is the entry point, and then it goes through right all the way through Brisbane and then gets back out. The last exit point is through Western Australia itself. So in terms of supply chain is really, really strong. And that's essentially where the southern polar launch location is. And soon we'll be getting an equatorial launch site as well. In terms of the value proposition in regards to the area, if you look at the area, we have about 450 square kilometers of launch site capacity and capability. The airspace is very clear. There's no marine parks at the moment. And in terms of launch aspects, cadence and trajectories, it's between 51 and 120 degrees for polar. This is specifically for polar. And we can even launch in terms of across the continent, because in terms of population, there's really a very low population at the moment. And so why Australian Space Super Corridor? Key aspects is like a real estate agent, location, 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 low impact on commercial aviation, low impact on launching and landing anomalies, retrieval opportunities is some of the areas that we're looking at. Environmental and social impacts are very, very important. ESG, we've got certification as a process that we will be going through in terms of ESG certifications for the green spaceports. Strong federal and state support. The state government is very, very much driving behind this, and essentially to provide a low cost and high impact, economic impact to the world, to the region, and there's a lot of federal and state funding available, including private funding going on at the moment. Thank you very much. Appreciate it.
Thank you very much, sir. And before I invite the next speaker, I'm going to invite the next 5 to come and sit closer to the podium. Dassault Aviation, France. So from Dassault Aviation, I request the delegate to, esteemed delegate to please join us here. The Exploration Company, we already have our delegate here. Imeria, France. Share My Space, France, and Leonardo, Italy. And with that, I now request Dr. Abhilash Chandra, SCBR in Australia, to please make his presentation.
Thank you. And namaskar, everyone. Dr. Somnath, Chairman of ISRO, Dr. Goenka, Chairman of InSpace. I'd like to thank you for inviting me here to be part of G20. Past 24 hours have been amazing, and I really want to thank everybody for that incredible experience. My background, my name is Abhilash Chandra. I'm Indian by descent, 3 generations removed from India, but India is still in my heart. I live in Australia now, so I've got the best of both worlds. I'm a little bit different to most people here. I'm a practicing vascular general and military surgeon. This is my 23rd year of service in the Australian Army. I've been an infantry soldier, medical officer, and now I'm the senior medical officer for 9th Brigade. I'm also an academic, so industry professor at UniSA and Future Industries Institute. And I'm also the founder and managing director of the Sabrin Group of companies. This background gives me a great opportunity to try and help deliver better healthcare to those who are in the world who need it the most. As we all know, 50% or more of the global population do not have access to adequate healthcare. The top left picture on this slide shows how the distribution of healthcare is globally. The darker areas are areas that do not have enough access to healthcare. So at this point, I'd made it my purpose to try and bring better healthcare faster to all the people who really need it. I've been developing the Sabrin eLife Pod. Basically, it's a transportable life sustainment pod that can provide an integrated emergency ICU and operating theatre capability. It can be transported by land, air, space, including the littoral zone, by a variety of different vehicles, which includes trucks, trains, planes, helicopters, amphibious vehicles, and boats. And when we look at starting to colonize extraterrestrial environments like lunar surface and Mars surface, I want to try and have the eLife Pod also providing the best healthcare for our people on extraterrestrial environments. So the eLife Pod is designed to have better diagnostic, better monitoring, and better treatment capabilities. It'll start off with ultrasound and X-ray. Future generations will have CT scanners. It'll have capability of managing airways, transfusing blood, and performing surgery. It'll have advanced telehealth capability, and it'll be built according to United Nations Sustainability Development Goals. I want to work with India to try and build this eLife Pod. My goal is to try and get the eLife Pod to not only be useful for the Gaganyaan projects in the future, but also try and provide better healthcare for India and the world's poorest as soon as possible, being in line with the one Earth, one family, one future. These are my contact details. Please feel free to contact me with any questions or queries. Thank you very much.
Thank you very much, sir. May I invite Dassault Aviation France, Mr. Philippe Da Silva.
So, good afternoon. Okay, and thank you for this opportunity to be with you today. I represent Dassault Aviation, a French company, leader and pioneer in the aerospace industry, both in military and in commercial sectors. And we have in this domain a very long history of cooperation with India. In the space sector, we are primarily focused on the design of reusable space planes and lifting bodies, which are at the crossroad of aeronautics and space, and which can benefit the most from mature aeronautical technologies. And we have been involved in many spacecraft projects since the 60s, ESA programs, NASA program also. And in all these programs, we have always been committed to apply our proven technical aeronautic skills, making Dassault Aviation a unique player in the space sector. So we believe in synergies between space and aviation, and we believe these synergies will become increasingly strong, particularly to meet the growing needs of the commercial sectors. Many of today's space sector challenges are indeed those that aeronautics sector was able to address yesterday. That is what we did over this last century. I'm talking about reactivity, reusability, flexibility, reliability, and of course safety. And we believe that such vehicles, such space planes, is a smart and relevant solution to address these challenges. So space planes are indeed a missing asset of the global space chain value. I was just talking about technical challenge, but space planes also bring key operational capabilities, such as return from orbit, which is still poorly addressed today, and for which we need to come up with more innovative concepts. Because the need to down mass is going to grow, whether it's people with development of manned flights, but also microgravity experiments, lunar samples, and we're working on such concepts in Dassault Aviation, because tomorrow it will no longer be a question of returning passenger and resources or equipment in the middle of the Pacific Ocean, but of operating on hourly schedules, returning as do airplanes at conventional airports, and using existing infrastructures. So these are some examples of all the capabilities that can address such orbital space plane. I won't go, we don't have time, but it's transport, cargo transportations, manned flights, and in-service orbit, and a lot of applications. Regarding our skills are a continuation of aviation technologies. We are above all a global architect and system integrator, mastering all the key technological skills for design, development, testing, production, certification, support of complex air system. And we have extended these key aeronautical skills to the space domain as an extension of the flight domain, faster and higher. As conclusion, I will say that over the past 10 years, the global space sector has undergone an unprecedented transformation and expansion, and as a player in aerospace innovation for over a century, Dassault sees this transformation as a great opportunity. An opportunity to meet new challenges, to make space more accessible, more responsive, more safe, more reliable, and also less expensive. And we are convinced that we have much to contribute to this transformation, and we seize a real opportunity to develop fruitful cooperations. Thank you very much.
Thank you very much, sir. We have next the Exploration Company France, Ms. Helen Huby.
Okay. So, hello everyone, and I'm going to bring you in space. Our mission is to democratize space exploration, so to make it affordable, that is to say accessible from a price point of view, to make it sustainable. We are the first in the world to fly a space capsule with green propellant, and to make it open. We are the first in the world to open source our interface, and we want to be able to serve in a cooperative manner International Space Station, American Space Station, and also Chinese Space Station one day. So you see here basically our vehicle, our vision. Our vision is to make basically orbital vehicle like Volkswagen makes car. Our vehicles are made out of 2 bricks, 1 capsule, which fly to space station around the Earth, fly to space station around the moon, and then comes back and then can be reused, flying with green propellant, a technology that we develop in-house. And the second brick is the trunk, the service module, empty or filled with cargo when we go to space station around the Earth, and when we go to the moon we need additional energy, so we develop in-house a cryogenic oxygen methane engine that enable us to go to the gateway and or to land at lunar surface, and that engine can be refueled in orbit, so hence we can use, for example, the Starship capability as a tank to be able to perform several missions. So these are like cool design, but probably you want to know where we are today. So we started working in September 21. Today we're actually 82 employees because we grew since that slide, so since last week. We've raised around about 55 million euro, which is a record in Europe. We closed the biggest Series A ever raised in Europe by a space company. That when there was war in Ukraine and double-digit inflation. And we are flying this year in October together with India. So thank you then to Radhakrishnan for the excellent cooperation that we've been able to set up with him. So we fly our first baby capsule second week of October, and it will be launched by PSLV. And in 24, we fly our subscale vehicle that will be launched by SpaceX. I want to show you some cool hardware picture, so that you can see that this is real actually. You see on the left-hand side our baby capsule that will be launched here from India, second week of October. You see in the middle the mid-size capsule, which is currently in the manufacturing process. On the bottom of the slide, you see our new integration room in Germany, and you see on the right-hand side the two in-house engines that we're developing in-house, green propulsion on the one hand, and oxygen methane for landing at lunar surface. And as a conclusion, I would like to thank again India for this amazing organization and for giving me the opportunity to present to you the exploration company, as well as for the great cooperation so that we can launch together this year our first baby capsule, and for the cooperations to come, among them a strong cooperation for the parachute and more to come. Thank you for your attention.
Thank you very much, Madam. And with that, I'd like to invite Emir of France, Mr. Philippe Gauthier.
Good afternoon, everybody. And thank you very much to give us the opportunity with my colleagues to present our industry. I hope I will survive to the buzzer torture. Okay, Emeria in brief, we are a medium-sized company, 70 million of revenue, 400 employees, 3 plants. And to summarize, we have 3 lines of products for space, but not only space, for sky also. Satellites, we design and make small satellites, balloons, and also we have a product line of equipments to make trajectography. Please, next. Oh, yes, I have the, I did not understand, excuse me. Up. Okay, fine. We propose small sats. Small sat means satellites which are under 100 kilograms and which address, I would say, 3 market segments. One is connectivity, mainly IoT. We are providing the satellites for a constellation called Kineis in particular. One product line is for Earth observation. And the third one, up to now, is only dedicated to defense application, is for space surveillance, and we are manufacturing right now 2 satellites for the French MOD to be in a geo-orbital orbit. And the purpose of those satellites is going to protect the key assets that the forces have in a geo-orbit. We have also under development a vehicle to take care about transportation of satellites up to geo-orbit. About the balloons. Balloons are systems now which are becoming again, I would say, fashionable. But just focus on the one category of balloons, which are stratospheric balloons. We are developing a maneuvering balloon, which is going to be able to stay at something like 20 kilometers of altitude during 6 months, and to stay stable in regards of the ground, so that there will be a lot of applications, Earth observation, telco, and so on, and it will be available in next year, in fact. And I wanted also to be brief to to talk about our last baby. We are also investor. We are trying to move also downstreams for space application, and it has been well said in the presentation before that the business is much growing in that arena. And we have created one year ago a startup which is going to focus on the subject of water, inland water, management of the water, prediction of disasters, with two segments. We are going to put in orbit a constellation of satellites to make certain measurements daily on 30,000 points on the Earth. And we have also, of course, a digital segment, which is providing data and services to manage quality and quantity of water. And of course, it's a key subject all around the world. Thank you very much.
Thank you very much, sir. And the esteemed delegate from Share My Space, France, Mr. Romain.
Good afternoon, everyone. Dear Chairman, I'm very honored to be here with you and to present to you my company, Share My Space. So we are a French-based company with a global ambition, and we work in the field of space surveillance and space operations safety and security. So we were incorporated in 2017 for one fundamental reason, Earth orbit congestion. So now there are more and more satellites in Earth orbits, more and more space debris that are causing increasing risks for the sustainability of human activities in space. So our fundamental mission is to tackle that. So how do we do it? So we've built a system that we called our Orbital Information System, which is a set of algorithms and database architecture, all secured. So we ingest, process, package, and distribute high added value data for our customers, who are institutions, military bodies, and commercial players in the space sector. So we ingest data from various sources, public sources, sources from partners, including our customers. And as a key part of our orbital information system, we control a network of optical stations scattered around the world. We currently have 4 operational optical stations. And we've actually designed, developed, and deployed the key innovation that we call the multi-telescope observation station. So it's an optical system made out of 4 optical telescopes that scan the sky and detect all the objects that cross an observation ring. So it works a little bit like a radar system would do, but using optical technology, which enables us to drive the costs down and to bridge the gap with the commercial market. So we've designed the system to be extremely sensitive in LEO, across all orbits, and in particular in LEO, also very, very accurate, so it enables us to address a wider market. So currently we detect even the smallest objects in the US catalog, both in LEO and in GEO. So going forward, so yeah, we've successfully addressed the key segments of our market, so institutions, military, and commercial players. We have 15 customers in 7 different countries around the globe, and we've really managed to package key products for each of these segments. So we are looking forward first I'd like to thank again the ISRO and CNES for having us here, and we're definitely looking forward to further collaborations with Indian partners. Thank you.
Thank you very much, sir. And ladies and gentlemen, before I invite the next speaker from Leonardo, Italy, we have Thales Alenia Space lined up. After that, I invite iSpace Incorporated, Japan, Sagri, Japan, and Unmanned Exploration Laboratory, Republic of Korea. So let me now invite from Leonardo, Italy, Mr. Sandro Panagini.
Good afternoon, everybody. Thank you for the possibility to present Leonardo activities and in special a focus on the space Leonardo activities. As you know, Leonardo is a global company that develops multi-domain operational capabilities in the aerospace, defense, and security sector with an integrated offer of high technology solution for military and civil application. 4 business sectors are managed by Leonardo. One is the helicopters through direct resources like the helicopter division and several cooperation and joint ventures. Another is aeronautics, then defense, electronics and security, and space. Space is, Leonardo is acting as with direct resources, providing activities, but through also the Telespazio, the joint venture with Telespazio, which is for the 70% owned by Leonardo, and Thales Alenia Space, which is owned of the 33% of the share, and also Avio for the launcher. So you can see that there is cover all the completely chain value of the industry space. It's worthwhile to mention that the 30% of share of Leonardo is owned by Italian Ministry of Economy and Finance, while the other is on retail market through institutional investor and on the market. 90% of the institutional float is international. Space. Leonardo covers the entire value chain of the space industry, from the manufacture of satellites and orbiting infrastructure to the production of high-tech equipment and sensor, in addition to developing a new space application and the management of satellite services up to propulsion and launching system. Through the joint ventures, Telespazio, satellite services for the design, development, launch, and in-orbit controlling space systems, and services and application for Earth observation. Through Thales Alenia Space, satellite system for telecommunication, navigation, Earth observation, probes and rovers for space exploration, and multifunction orbiting modules. Directly, with ordinary resources, Leonardo provides instruments and equipment. Instruments, electro-optical instrument and hyperspectral payloads, laser transmitter and robotic system for space exploration and the study of our planet. And as equipment, photovoltaic panels, atomic clocks, attitude sensor, power distribution system, and orbital micropropulsion. Just to give you an idea where the equipment and the instruments of Leonardo are in the solar system, we are far of the solar system up to close our system. Just to pick up two information or two of these missions. One old, that is New Horizon, for example, launched in 2006, in which the Star Tracker developed, manufactured and developed by Leonardo, owned the proper engagement to the planet and the proper flyby to Plato's planet. While one of the most recent is JUICE mission, in which Leonardo provide the PVA for the power of the craft. We are speaking about 85 square meters of PVAs, the biggest for exploration ever built till now, and two important instruments, one high resolution camera and a spectrometer in the visible and infrared spectrum. So those are the capabilities of Leonardo, that is provide a wide range of high reliable solution for Earth observation, science, planetary exploration, navigation and telecommunication program, based on a long-standing collaboration with Italian Space Agency and the European Space Agency. Thank you very much.
Thank you, sir. And may I invite from Thales Alenia Space Italy, Mr. Vincenzo Giorgio.
Good afternoon, and again, thank you for giving me the possibility to show up what Thales Alenia Space does in space. I could simply start with a statement that says that we do everything but launcher, meaning space infrastructure, telecommunication, Earth observation, science, exploration, and navigation. And in this picture, you can actually see all the orbits and all the products that, by the way, are very well flight proven since the last 40 years. So you see at the list of the chart, the Mars, where we have an orbiting system there waiting for the rover to go. Our motto is space to, meaning that space to observe, space to defend, space to explore, and so on. So that's the way we divide our disciplines. Let's start with space to observe and navigate. I'm referring specifically to a very specific competence of Italy in the radar system. It all started with the Cosmos SkyMed, Constellation 6 satellite going on, and 2 ready to fly, which allowed us to go into the position of a main actor of the ESA EU Sentinel for the Earth observation, whatever field. I mean, a radar, hyperspectral, as well as optical observation. We have now developed, and we are under a contract to fly Constellation for the high-resolution radar systems. The reason behind that is the increase time revisit that is very much required by the customers. Satellite ranging in the weight average of 200 kilograms and in a Constellation mode. Going to navigation, we are building the second generation of the Galileo system in Europe. Then Air to explore, space to explore. Our heritage starts from Space Lab, therefore we are talking of the 70s, more or less, or the 80s, and we've been working on the International Space Station, where we have a major role. I mentioned the fact that Thales Alenia Space has built more than the 50% of the habitable volume, and we are today the major actor in the building of the Lunar Gateway in terms of habitable volume. We have the International Lab, we have the Esprit module for the resources, we are building the US-led HALO under contract with a US prime, and we are developing under the Italian Space Agency a lunar habitat on the surface. We are also participating to the commercial LEO development with a number of actors. Today we have a contract in place with Axiom, and you see the 2 modules, flight models being already manufactured in TAS, and we have the Martian mission ExoMars. We already have a satellite flying around Mars. We will land the rover in 2028. Actually, it would have been launched in 2022, but due to the crisis in Ukraine, the launch was delayed for the existing cooperation between Europe and Russia, which was actually destroyed. This being said, we are very much active in trying to look for area of cooperation with India as well as with other countries, including the possibility to localize some of the production that we have. As you see, what we need here is be competitive, and we're trying to do everything allow us to do that. Thank you very much.
Thank you very much, sir. And now I invite from iSpace Incorporated Japan, Mr. Masayuki Urata.
Good afternoon, everybody. My name is Masayuki Urata, Sales Officer of iSpace Japan. Today, I would like to give a presentation about our company and our recent mission, and also about our future missions. But before that, I would like to mention that the keyword is, let's go to the moon together. So this is overview of our company, iSpace. So we were established in 2010 with a long-term vision, Moon Valley 2040. Currently, we have employees with 200 people from over 25 countries located in Japan, USA, and Europe, Luxembourg. So we are developing lunar lander and lunar rover, and as asset, we have Mission Control Center in Tokyo. And we are providing a payload service. It's a transportation of cargo from the Earth to the moon. The second one is data service. We are providing flight data to the moon and also lunar data. As for the financial achievements, we would like to emphasize that we successfully raised over $200 million before IPO. And in this April, we succeeded in IPO in Tokyo Stock Exchange growth market. So it is the first IPO as a startup space startup in Japan. And this is the overall overview of our mission 1. So we launched our first lander to the moon last year in December. And we attempted lunar landing in April 2003. Yeah. So unfortunately, the result was ended as hard landing, but it is very important that we identified the root cause of the hard landing as a failure, and we can reflect such lessons learned, utilize lessons learned for the future missions. Yeah. Then as you can see, so we successfully took some pictures in the lunar orbit, and also there's some analysis as a hard landing. Then you can check our detailed analysis in the YouTube, but it is a kind of software error related to altitude measurement. Yeah. Then this is our future missions. We have two future missions now specifically planned. Yeah. So mission 2, we are going to use the same lander, and as for mission 3, we are going to upgrade for commercialization, which has 500 kilograms payload capacity. We are going to launch mission 2 in 2024, next year, and mission 3 in 2025. As for mission 3, we got a big contract from NASA under CLIPS program, and we are going to bring 100 kilograms of NASA's payload to the far side of the moon. We are going to bring 2 commercial communication satellites together with this lander. Yeah, if you are interested in a lunar mission in the future, so please kindly contact us, and let's go to the moon together. Thank you very much.
Thank you very much indeed, sir. And before I invite the next presenter, may I invite presenters, the next set of 5 presenters to please come and take seats close to the podium. Unmanned Exploration Laboratory, Republic of Korea, Glabcosmos, Russia, Inmarsat, UK, Mithira Global Communications Limited, and Voyager Space, USA. And now I invite from Sagri, Japan, Mr. Satoshi Nagata. Sir. Green button for the going ahead.
Okay. Nice to meet you all. And at first, I'd like to thank you, ISRO team and the admin team for today. Nice to meet you. I'm Satoshi Nagata from Sagri. Our company from Japan, established in 2018. Actually, we have a company in Bangalore here. Actually, I'm leading the Indian engineering and sales team. I'm leading from India. Yeah. Actually, our company in our world, we are utilizing the satellite images, AI, mapping technologies. We are utilizing these 3 key features of technology and supporting farmers in emerging countries. Okay, this is an example of our technology. We have 2 key features. Yeah, one is the auto mapping of farmland. We are, for example, in emerging countries, farmland is scattered. For example, in Himachal Pradesh in India, scattered and hilly, it's very difficult to track. But however, if we use Sagri technology, we can map easily. Based on this mapping, after that, actually we can check the total carbon, available nitrogen, pH/cc, main chemical indexes we can track. Maybe based on these analysis, we can optimize the fertilizer. Actually, in this scenario on the world, fertilizer cost is 2 to 3 times, and also the limitation of the supply of nitrogen. That's why farmers are suffering of the high cost of fertilizer here. To deal with these challenges, we Sagri can provide the optimization of fertilizer based on satellite image analysis. Then, after these analysis, we can support farmers like these, based on satellite image analysis of farmland. Then we can suggest farmers to please decrease chemical fertilizer. Based on that decrease, farmers can decrease the greenhouse gases from the farmland. Based on these degrees of greenhouse gases, we can contribute also to the a carbon neutral situation in the world. Then after that, farmers can get the carbon credit revenue from in the voluntary credit market. Yeah. In this concept, we Sagri working actually from India and Kenya, Thailand, Vietnam, all over the world. We'd like to work together. So and friends from the world today, if you would like to partnership with us, yeah, we are open today. And also I'm based in Bangalore, so maybe whenever you are free, we can have a call each other. Thank you for listening. Dhanyabad.
Thank you very much, sir. And ladies and gentlemen, next we have from Unmanned Exploration Laboratory, Korea, Mr. Yongsub Kim. There you go, sir.
Hello, ladies and gentlemen. I'm Yongsub Kim, project manager at Unmanned Exploration Laboratory. UAL is a South Korean robotics startup specializing in making rovers for space. UAL provides many different robotic platforms for use in exploration. Our catalog includes conventional aerial drones, rovers on ground vehicles, as well as simulation chambers to test lunar equipment. As a leading startup aligned with Korea's national space policy, we have partnered with key national research institutes in aerospace, construction, and nuclear energy, and are paired with multiple government projects for space exploration. We have built and tested multiple prototypes of lunar rovers. We have small few kilogram two-wheel rovers to large four-wheel rovers with dedicated suspensions and solar panels. We are also experimenting with foldable chassis and fierce technologies that allow our rovers to be packed into small space and be available for more missions. And this is our foldable wheel rovers, and we can downsizing our wheels like this mechanism. Okay. We also have separate technologies for 3D printing technology that can use lunar regolith and manufacture synthetic lunar soil for experimenting lunar equipment. We are going through these projects with various partners, both in the public and private sector. We have institutions with whom we are developing a lot of these foldable structures. These partners are critical for us to gain access to advanced technologies such as new materials testing in their space environment. Our startup is located in both the capital Seoul as well as factory in a nearby city of Ansan. The pride of our facilities is a lunar environment test bed of 10 square meters filled with lunar regolith simulant. Also, we are collaborating with science YouTuber Minani to increase public interest in the space industry in Korea. If you have any questions, feel free to contact us in the email address here. Thank you for hearing my presentation.
Thank you very much, sir. And with that, now let me invite from Glabcosmos, Russia, Mr. Dmitry.
Good afternoon, dear colleagues. I didn't bring any portable demo objects with me as the previous speaker did, but I will try to surprise you and flip my presentation backwards. This is a very complicated chart that just justifies our presence here. All of you know how important all of us are in the space industry for the space economy, and since we are in the Space Economy Forum, I thought it would be necessary to show this. This is a tribute to what the Director General of Roscosmos mentioned yesterday, the future in fact not the future, but the forming Russian multi-constellation of satellites of different types. Several of them have already been launched. And this is in essence what the business of my company is. GlovCosmos is a 100% subsidiary of Roscosmos State Space Corporation. We were founded in 1985, and since then, India was one of our main partners in international space business. In fact, the core business of our company, the most probably important part of it, is providing launch services. In fact, one of the last launches was from the newest Russian spaceport, Vostochny. We organized the launch of 42 piggybacks, 42 secondary payloads. We also propose commercial space flights to the ISS. The next launch opportunity will be in 2025. By the way, speaking about secondary payloads, all opportunities for this year are booked already, but we have every year at least 2 to 3 opportunities to put here payload on a federal Russian launch. Finally, I would like to commend ISRO for the great work it is doing with the private companies. We in Russia, the Russian government is also turning to the private space business, and recently GlovCosmos was authorized to tackle interaction with the Russian private companies. So, summarizing, we act as a one-stop shop for the whole Russian space industry. We're facilitating your contacts with a very complicated official, sometimes bureaucracy. That's well known how it happens. So you're most welcome to address us, and let's go to space. Thank you very much.
I'd like to now invite from Inmarsat UK, Mr. Gautam Sharma.
Good afternoon, ladies and gentlemen. Thank you, both the chairmen, for giving me an opportunity to be part of this session. I'm Gautam Sharma, Managing Director of Inmarsat India. And we've been giving mission-critical services to the Indian government for last 2 decades. We've also recently started giving in-flight maritime services to our Indian customers. We have also been recently acquired by Viasat, which makes us one of the largest satellite service provider in the world. The mission of the company is to connect the world, because we believe whenever everyone is connected, the possibilities are limitless. As I said, together, Viasat plus Inmarsat becomes a $4.1 billion revenue company with EBITDA of $1.4 billion. And the enterprise value of Viasat becomes $14.8 billion. We have a constellation of 19 satellites in Ka band, L band, and S band. And in addition to this, we are also planning to launch 10 more satellites, including 2 satellites in HEO orbit to give connectivity in the Arctic region. The market which we will be addressing by 2030 would be $1 trillion market. And we have around 8,000 employees, out of which 300 employees are based out of India. And we also have global offices in almost 90 plus places, including 3 offices in India, which includes Chennai, Hyderabad, and New Delhi. And we have patents of 2,500 plus jointly. The focus of Viasat entity would be on fixed satellite services, giving high throughput broadband connectivity to consumers, strategic government services, as well as mobility services. The key markets would be commercial aviation, business aviation, maritime, space, tactical networking, etc. We also believe the future lies towards broadband and IoT, and that's why the focus would remain on energy, aviation, fixed, government, maritime, and on the IoT side, on tracking and monitoring and analytics. As I said, we believe in connections, and our focus remains on sustainability because we strongly believe protecting environment is important for every citizen, community and charitable giving, and diversity and inclusion. These are few of the customers which we're already serving in India, which includes Vistara Airlines. They're using our safety broadband solutions in their cockpits. In addition to SpiceJet, where we have in some of their 777 Maxes, our Global Express services. We also serve Great Eastern Shipping Corporation of India by digitizing their maritime vessels, Shipping Corporation of India, and similarly, we're also giving connectivity across board to defense forces, which includes Swift broadband as well as fleet broadband and in-mass at sea services. That's all from my side. Thank you very much.
Thank you very much, sir. And now may I invite from Mithera Global Communications Limited, Mr. Ravi. Sir.
Okay. Start working? Okay. Good afternoon, ladies and gentlemen. My name is Ravi Alawadi. I represent Mithera Global in South Asia. Mithera Global is a UK-based company making constellation of MEO broadband satellites. Our motto is to provide services anytime, anywhere, instead of every time, anywhere. Ours is steerable beams. The satellites are at 19,500 kilometers. The filings are in the Ka, QV, and W bands. The constellation is of 128 satellites, out of which the first 12 satellites will go into the orbit in December, starting December 2024. The other part, which is very important for us, is the low-cost terminal which we are developing. It's a terminal which is developed under the leadership of Mithera with the consortium of some companies. The design is at this moment proprietary, working for Ka band, but I'm pleased to announce that very soon this terminal will evolve to switch over to the other bands, including Geo, Leo, and other bands. This terminal has two usage, one for the residential users, up to 300 Mbps using 60 centimeter antenna, and 1.2 meter antenna giving up to 1 Gbps speed. These are our main markets, starting with the residential enterprise broadband services, GSM backhaul, government for digital rollouts, services including the earth monitoring, military and defense, other data and communication services, disaster recovery, and rescue services. Just to conclude, we are a bridge between MEO, bridge between Geo and Leo, and we are totally aligned to what has been mentioned every time, Vasudhaiva Kutumbakam, which is one earth, one space, one family. Thank you so much.
Thank you very much, sir, for that very crisp presentation. And I'd like to now call on, before I call on Voyager Space USA, may I also invite the esteemed delegates from Eliana, Singapore, Indra, Spain, Satlantis, Spain, PLD Space, Spain, and Hindustan Aeronautics Limited to be closer to the podium. And I invite Mr. Marshall Smith from Voyager Space.
Thank you. All right, thank you. So we'll go ahead and get started. So at Voyager Space, I talked a little earlier, we're building infrastructure. We're trying to have inventive space infrastructure and diversified technical solutions. A lot of mumbo jumbo there, but what I'll say is, you know, this is what we're mostly known for is Starlab. Starlab is, Voyager is building the first commercial space station. We will launch this all in one single launch. It is a fairly large system. It's about 40% of the ISS pressurized volume. It has a power propulsion system, 60 kilowatt power propulsion system, The actual research system that's in the vehicle will have 100% of the payload capacity of the ISS, actually, and then some. We'll have a robotic arm and a science airlock showing, actually, that's our Bishop airlock that is on the ISS now. And then we'll have an equipment bay behind it where we'll keep most of the equipment. So, you know, this is a very large system, much larger than anything that has been launched in the previous systems as we move forward. We eventually will add on 1 or 2 modules to it, but in the long run, we plan to launch multiple of these stations because we really want to look at the focus of what we're doing. We want stations to be focused on research. We want them to be focused on manufacturing, maybe tourism, other things like that. They all have different needs, different types of customers who really don't play well together. You know, you don't want to be doing advanced microgravity research next to somebody who wants to play their music really loud as they move forward, or doing manufacturing that's dirty. The other things that we do that maybe aren't as well known is we're into orbital servicing and space sustainability, spacecraft communication systems, propulsion systems, both solid and electric systems, Earth and space visualization, ISR, and other advanced solutions. So just really quickly, you know, one of the things we're looking at is how do we recycle upper stages to be used as outposts for Earth observation or other types of research that folks might want to do as we move forward. Airlocks, of course, we do the Bishop airlock now. It's the first commercial real estate that became a perfect permanent addition to the ISS in 2020. We use the Bishop airlock to move it. It's actually very large. It's a little bit, I can stand up inside it, and we put payloads in it and expose them to the vacuum of space as we move forward. We do launch and mission management systems. NanoRacks, one of our companies, has been doing research on the ISS for over a decade. I've launched over 1,500 payloads. We're the largest launcher of payload systems to space with that. Moving on. We're doing orbit servicing and sustainability, refueling systems, those types of things, capture management systems, dog tags, where you can use electropermanent magnets and connect to facilities, connect in space so you can capture them and then either refuel them or remove debris. Communication systems, laser and RF communications. We have been doing RF communications for quite a number of years, as well as laser communications, digital systems, electro-optics, and custom communication systems. As I said, solid electric propulsion systems, and then Earth visualization systems. We have ISR capabilities that we use. And then finally, you know, other solutions that are out there. For example, we're involved with oxygen development on using lunar regolith and other minerals, and how do we go use those, as well as launch pad infrastructures, ground systems, and things like that. So with that, I'll leave it. Thanks.
Thank you very much, sir. And now from Aliena, Singapore, Dr. Mark is going to present. So, the green button is to go.
Sure. Deployment of satellites in small to large constellations. Our core product today is the multi-stage ignition compact Hall thruster, or in short, Music Engine. Music offers cost-effective performance, making it the industry standard for satellite platforms interested in compliance with deorbiting regulations, enabling operations of satellites in constellations